Well, good afternoon, everybody. It's really a pleasure to be here. And I must say, just before I start my talk, I've been really enjoying this talk and listening and learning everybody. And as one of the more older senior AmeriFlux people, I'm really excited that I think we're in great hands. I really see a lot of competent next generation leaders and students and postdocs and technicians that really it's great to see this grow, which really gets back to kind of the topic. Margaret and Trevor asked me to kind of speak about AmeriFlux, and since so many of you are kind of young and new to this, I'm going to give you a little bit of background on where we came from, where we are, and hopefully a few ideas of where we all can go. And really the idea is I like to study complex systems, and one of the attributes of these complex systems is that the whole exceeds the sum of the parts. And I think this is why AmeriFlux has been successful, because we do operate on that way. If you think about the history, I mean, it's changed radically. Some of the pioneering work on eddy covariance and CO2 measurements really started in the 1980s. Department of Energy with Gail Bingham and Roger Dahlman invested in building one of the first open path CO2 sensors that was developed by Gail Bingham and Lawrence Livermore. And there's 3 copies made. Shashi Verma at Nebraska had one. Bruce Hicks and Marv Wesley had another, and Gail kept his own just for testing. The other sensor was homemade by Ray Desjardins. So when you look at the first measurements, there's maybe 30 hours of data, essentially. You were out there in the field looking at every moment of measurements. And they were kind of like Lone Rangers, essentially. Steve Lofsey was actually one of the first ones to be crazy enough to put the sensor out for a year, but he wasn't a micrometeorologist. He was an atmospheric chemist, and any micrometeorologist would never have done that. But LICOR had built one of the better closed path sensors that was kind of reliable, so they could put it on the tower, run pipes through it, and start making the measurements. And so around then, I was on sabbatical with Ricardo Valentini in Viterbo, and he says, there's this new paper by Steve Lefsey. They're trying to make year-round measurements, and both of us are interested in ecosystem ecology, so he said, hell, let's do it. And with Boreas, which is a precursor to your project you're talking about, Andy Black was funded to be able to keep a long-term system going on the Aspen. So this is all 1992, 1993, essentially. So finally, we got funded for AmeriFlux. We got funded for FLUXNET. A lot of the motivation was like today's discussion of linkages between satellite remote sensing and flux work. It was kind of modus validation. And we had our first workshop here in the Marconi, kind of where my great-grandfather had his dairy, essentially. And we brought in about 30 people from across the world. And we had that first special issue in global change biology. And there we had maybe 100 site years of data. And slowly it kind of grew with the various ones. And now I think we're kind of like Manchester City. Who's a football fan? De Bruyne, my favorite. But they succeed because they work as a team. They have really good players, but it's a team. And so really for all of us to think about is we need to keep going. And so thinking about funding, generational training, etc. So I wasn't sure to put this slide first or the other one, but just to give you again some perspective, we were a small group. We got to know everybody pretty well. It was just a few of us kind of spread across the United States. Kim uses that great term as a coalition of the willing. I really like that. And it really was, essentially. Many of us actually were trained either through Shashi Verma or with Tilden and I through Bruce Hicks, essentially. So Shashi actually was a great grandson of Von Karman, and Bruce Hicks, I think, was a grandson of Swinbank. So luckily, we actually had foundational training in micrometeorology to kind of start looking at all the challenges of making long-term measurements. Sensors evolved over time. I mean, the early days, Dave Hollinger, Walter Schell, and us really relied on homemade CO2 open path sensors that Tilden Myers and David Obel and Bruce Hicks made at our lab. We had to actually create the first software to read the digital sensors. We worked with floppy disks. We couldn't even save our raw data. So we actually had to do digital recursive filters to actually calculate covariances. So it's changed completely. So in essence, the early days, how can we make reliable measurements 24 hours a day, 7 days a week? And when the sensors were imperfect, we had medieval, at best, rudimentary data storage systems. We had to really ask these key questions about the limits and the assumptions of the eddy covariance, because We're interested in moving from farms. So many of us were trained in ag meteorology, and now we're trying to do forests. Oak Ridge was really heavily next to coal power plants to fund the nuclear systems. So we had to think about that. We had to develop our software from scratch, and then slowly we had to come up with gap filling measurements because we really interested in answering ecological questions. What's the 24-hour flux? What's the yearly flux? And clearly we couldn't keep every data point because things go bad essentially. And then the beauty is we finally created a culture and infrastructure to share data, which we're here from now. And I really thank our colleagues at Oak Ridge National Lab that were some of the pioneers of this that helped us. But in the early days, people just kind of kept their own data on a disk and a spreadsheet, and we didn't share. And when I came to Berkeley, Deb Agrawal and Catherine Van Engen from Microsoft knocked on our door, and they'd worked with physicists on big data systems, but they were getting bored with that, and they wanted to save the world and work with environmentalists. And so that really led to the collection that we have now. And it's really nice because we do have this adult supervision by these experts like now Gilberto and others throughout the lab here to really produce data that you all can download and use and do science. And I think we've done something right. I mean, just a simple plot of citations of AmeriFlux and number of publications. I mean, it's really been this exponential increase over time, essentially. And so just to sell ourselves to your consumers, we are making direct flux measurements of carbon and water from ecosystems. Everything else is inferred. And so we are the gold standard for so many questions. And I think this is really important. But what's really neat is we can do so many things with this flux data because we're measuring fluxes at a given site. So we have a lot of temporal variation that we can explore, both on hourly basis and days and years. We can start looking at experiments across landscapes by natural gradients, ecological gradients, management gradients. We can look at the effects of fires, forestation, et cetera. And as our records get longer enough, this is why it's so important for you all, is that we now have 20 to 30 years of data. It's long enough now to start looking at trends and how ecosystems are responding to warming, to bursts and booms and rainfall, to carbon dioxide, essentially. So the reality is we really have this rich data set, and it's more than just carbon fluxes. Um, First of all, carbon and water are coupled, and that's important for our interpretations. It's also important that we partition our fluxes between the soils and the vegetation, and we can. Clearly, we are measuring everything that we can think of, if not more, and so we can look at environmental responses for our fluxes. And then the cool thing at the ecosystem scale is it's a complex system, and there's so many scale emergent properties. Light use efficiency depends on diffuse light. It's much different than a leaf, essentially. Rain pulses are affected by the litter, essentially. We see tightness between soil respiration and root exudate. So these are all things that we didn't know before if we just measured with chambers or if we just cut down trees and weighed them or looked at tree rings. So it's a really rich data set that we have. And then clearly we provide information for the lower boundary conditions for climate and meteorological models. So we have data on albedo, on surface roughness, on stomatal conductance, et cetera. So it's really cool. I was talking to some friends when I first wrote my DOE project to Roger Dahlman in 93 or so. I was so worried I wouldn't get funded because there was a year of data from Harvard Forest and I wanted to measure CO2 fluxes in a forest in Oak Ridge. Well, I think we've gotten over that now. We have thousands of years of data and we can actually produce these nice histograms. I always like when Housen has given us some presentations for our FLUXNET workshops. He was looking at different editions of this plot. And the first year I did it, it was really noisy and stuff. And as the data sets got bigger and bigger, we get a much smoother histogram. But it really tells you the range of possible conditions. The upper limit's maybe minus 700 grams per carbon. For perspective, if you take a piece of paper and weigh it and scale it to a meter, that's 75 grams. So we're actually a net flux of about 10 pieces of paper at the highest level. Clearly, you can have a lot of disturbances and carbon sources also. And so sampling that is important. To me, one of the biggest lessons we've learned really is this here is that changes in GPP scale with ecosystem respiration. And so the interesting thing is, again, because of this exudate to the microbes, if conditions are favorable for an increase of GPP, it comes with an increase of respiration. And that slope's about 85%. So the net ecosystem exchange is actually really small because there's a lot of respiration. And I think consumers of our data don't quite appreciate that. And more so, the old modelers were completely wrong. Peter Cox and his group actually predicted this death of the Amazon because they thought when there was drought, higher temperatures would lead to more respiration, that would lead to high CO2, that would lead to more warming, that would lead to more death. But in reality, that warming will reduce GPP and reduce our eco. So I forgot who showed that one plot of the different predictions of that. I mean, they're way off because they didn't know this lesson. And so working with the modeling benchmarking, like we've done a little bit with Jim Randerson, is really, really critical. So that's where we are. It's only about 15 minutes. I thought I'd just kind of give you some ideas. And this is just really rough off the top. It's just some low hanging fruit, especially since there's so many smart people here with new skills that we don't have. You know, what are some opportunities? I think one of the challenges we all have is how to disentangle multidimensional data. Because things are happening simultaneously. Temperatures changing, light's changing, soil moisture changing, VPD is changing. And in my early days as a student, people just kind of looked at, multiple linear regressions that don't deal with what we see in real data sets. They're nonlinear. They have thresholds. There can be disconnections. And so there are new mathematical methods out there with machine learning. Being at Berkeley, my first student, Nancy Kang, was Stanford, and she was really good at statistics. And she had discovered this method called alternating conditional expectations that was developed by Leo Bremen, a famous statistician at Berkeley. So recently I found there's MATLAB code for it and there's some Python code. So I said, shit, let's write a paper on it. And it's really nice because it really can tease out the effects of, for in this case, just evaporation of photosynthesis and stomatoconductance, VPDs. You can see these nice thresholds and stuff. And as Josh says, if you can't simulate Tonantzin Ranch, you can't simulate most of the world because it goes from very wet to very dry. So it's a really nice method. Cove, who's here, I hope still, was also really brilliant. And we were just reading some cool papers from Ben Rudell and Praveen Kumar's group out of Illinois. And they were starting to develop information theory, for example. And again, I think these are nice approaches because they can look at what variables are driving our different fluxes to different degrees. So that's kind of one line of thought. Kim's trying to push the idea of nature-based solutions, and I think that's really important. And so we can start to think about, are drylands a good carbon sink, Marcy? Maybe not. Wetlands can be really good because they're flooded, and so that reduces the amount of decomposition and respiration that's going. So they can be long-term sinks because they grow peat. In our delta here, we'll have peat that's 4,000 or 5,000 years old, and it builds up to 10 meters. So that's really good. But unintended consequences, it produces bodacious amounts of methane. And so again, having this connection of AmeriFlux with remote sensing, methane, upscaling, because we can't put flux towers everywhere. But as we talked last couple of days, if we can scale our flux data with remote sensing, and then we can apply it in a cost favorable way to our clients, I think we can make progress. Questions we couldn't ask when we first started because we didn't know how long this network would be is, how do fluxes change with time? I've mentioned already, CO2 is rising. I was born in 1955. CO2 was about 315 parts per million. We're at 420, 25 or so. My bones are seeing 100 ppm extra of CO2. What's that do? Our sites have warmed by 1.5 degrees, essentially. And the mess here is for these sites I can get data on, it's a mix. Some sites are flat, some sites are losing carbon, some sites are gaining carbon. So I think we need really smart people to kind of dive into this to understand what are these trends, in addition to the interannual variability. And we can kind of tease out the GPP, and again, it's a mixed bag. So things to think about. So kind of also to kind of end with the extrinsic contributions, I think we can really play a good role on land, vegetation, atmosphere, climate interactions, improving remote sensing upscaling, tied into biogeochemistry. hydrology is a big one. Carlos and others are working with OpenET, for example, to share water better. I'm a Californian, and I realize that Mark Twain was right. Whiskey's for drinking, water's for fighting over. And we have a $4 trillion economy with really tight water limits. And so how can we feed the world with our wonderful cornucopia of crops here and do it well? And so I think we can play big, big roles here. So in conclusion, I think we've exceeded our hopes and dreams. I think we've really worked well because we've gotten each other to know each other, to share ideas, to really be open with one another. I think that's really important. Luckily, we've had some good, stable funding over the years from DOE and many of the state agencies, essentially. But I think our work is really important because I think we are the canary in the mine with regards to global change. And so always defend ourselves. When you start talking to your local newspaper or your senator or congressperson, create that elevator speech, tell them what you're doing and why, essentially. And I think ultimately we really have to have a good generational transfer and really let you guys spread your wings and fly. But I think also you have an obligation to kind of keep this whole endeavor going. Ecosystems operate on ecosystem timescales. That's not a 3-year budget. It's a decade. It's 50 years. It's 100 years. Our wetland situation, for example, we cannot turn that off because if we quit flooding, it gets drained and that CO2 goes back in the atmosphere. So we have to educate our stakeholders of this. So I think I'll stop. I hope there's time for a discussion and conversation. If not, thank you.
Sure. Thank you so much. We have time for one quick question. There. Brian.
Yeah.
Thanks, Dennis. Really nice talk. So your point about the GPP going up and the RECO going up and the NEE kind of staying the same, I totally agree. That's really interesting. We've seen that across a lot of sites. I wonder, are there cases where that really falls apart and we don't see that? And do you know what would cause us not seeing that?
Yeah, it happens when there's disturbance. So when there is disturbance, we'll actually see that elevation. But even there, it's kind of funny as these systems recover, they still kind of follow that line essentially. So I'd say most of the cluster of the line is below the 1-to-1 line, but then you'll see a bunch of dots above it. And those are the sites that have burning and things. I mean, Marcy did this work with Mike Gould, and those are data points from you, actually. That's what we learned. And it's interesting, like let's say a forest burns up in the boreal forest. These trees will stay standing as snags for maybe a decade. Then they'll rot and they'll fall on the ground and they'll touch the ground and they'll decompose much faster. So there's lots of leads and lags in some of these processes also.
Yeah, I've seen it a lot in disturbances too. I was thinking about your graph of like time. So the long-term data sets with the forests kind of not seeing any particular trend. And I was wondering if for a lot of them, maybe there's just increased GPP, increased RECO.
And some of that, we just need more data. I mean, we've kind of cobbled those plots. Can you see me again? I lost it. Oops. Can you put me on or not?
Yeah, the time series are not usually long enough to detect a trend, right?
Yeah, I think you're talking about this plot here, essentially. Yeah, this one here.
I know which one.
What's not there? I can see it. Yep.
Sorry, that was not a short question, but
yeah. But yeah, a lot of it comes from the Canadian sites in Boreas, for example, in FLUXNET Canada. So, and a few, I think, from Northern Arizona with the fires and stuff, a few other places. So,
thank you.
More of you to take data.
And I know we have one online question.
Oh, okay.
Yeah, hi. This is Michael. When you're looking at the ecosystems that you have in AmeriFlux, and you're really looking for these long-term trends, do agro-ecosystems actually then belong into that cohort, or shouldn't agro-ecosystems be very different because they are constantly disturbing and they are constantly dynamic, and they are also important for other gases such as methane and nitrous oxide? Or shouldn't agro-ecosystems be and they are right now only forming a small percentage of AmeriFlux, shouldn't they be carted out and put into some type of a different environment?
That's a fair question. I mean, I've been looking at some of the longer data sets from Andy Suker and Jerry Hatfield, and we're now collecting data from our alfalfa sites. And I think management is much stronger variable in affecting those ecosystems than climate change. Is kind of slow. I mean, farmers can pick and choose their crops to kind of minimize these things up to the can. They can irrigate when they need to. So it's ag systems aren't facing the same pressures that natural ecosystems are, especially in terms of drought and CO2 and limited nutrition, for example. So yeah, that's a fair question. But this is why I want the young people to start looking at these trends and ask these type of questions. Often I teach ecosystem ecology and students will ask me a complex question. I says, it depends. So always think of the conditionality because this is the reality. So yeah, thank you.
So much. And so we are going to jump to Australia and welcome Stefan Arndt and Peter Isaac.
All right, thanks everybody, and thanks for inviting us. My name is Stefan Arndt. I'm from the University of Melbourne, and this is a team talk with Peter Isaac, who sits over there. But we agreed that I would do the talking and not Peter, because we would not keep to the 10 minutes that we been allocated if the both of us would stand up here. So similar to Dennis, and we didn't compare notes at all here. I'll give you a short overview over OzFlux and TERN. You heard about this term TERN. What is this? So OzFlux started in the late 1990s with a couple of towers, one in Hart Springs in Darwin in the tropics, run by Derek Eames, and one in Tumbarumba in New South Wales, run by Ray Looning. And then as we moved on into the early 2000s, there was more flux towers established in Australia, and the OzFlux community, as we know it today, was established. And then in 2010, TERN came along. So Terrestrial Ecosystem Research Network is a federally funded research initiative that funds a number of different activities in Australia, and flux sites were one of them. So there's about 12 sites that were established with individual site PIs. And in 2019, TERN combined what we had as super sites and the OzFlux, TERN OzFlux network into TERN ecosystem processes. So what we need to understand is that OzFlux as a entity, and here is the steering committee of OzFlux, is a community of practice. So it's all the people that are operating flux towers in Australia. And we have a steering committee that meets monthly, and we do an OzFlux newsletter 2 or 3 times a year. We have a web page in which we share information about our sites, ozflux.org.au. We run an annual OzFlux conference, very similar to the AmeriFlux conference that we have here. And we have an annual data flux workshop where we invite anybody who likes to learn about flux data processing to come along for a week, and we'll teach them how to do it. And of course, we also run a data portal on the web page, and you can see this here. We have a list of all the sites that we're running in Australia and in New Zealand. But then there's TERN ecosystem processes, and that's really the funding source for many of our flux towers. So this is a flux site, as ecosystem processes here is the sites that have a flux tower associated with them. Then we have TERN landscapes, which is our remote sensing community. And then we have TERN ecosystem surveillance, which is a plot network in Australia. So we're dealing with ecosystem processes, and we're running 7 sites that have flux towers only, and we're running another 11 sites that have additional measurements, including a flux tower. So we do biomass measurements, acoustics, phenocams, leaf area index with dredge laser scanners, and we're implementing dendrometer measurements now as well. So it's a whole suite of measurements designed to understand how ecosystems are processed better. And what we're aiming to do, and you see this on the right-hand side here, is to change the model how we operate now from individual site PIs to regional hubs. So we have then full-time regional hub technicians that are based in Perth, in Melbourne, in Sydney, in Cairns, and in Darwin, and they're servicing a number of flux sites. And at the moment, we're not doing that. And this is very inefficient and leads to issues around data coverage. So we're covering the Australian climate landscape reasonably well. We can see this here in the flux data that we have in this old paper by Jason Barringer. We have now a number of really long-term data sets, like the one that you can see here from Tambaramba. And of course, you can do lots of interesting things and analysis with these data sets, as we can see in terms of water use efficiency from Tambaramba and how it springs over the course of over 20 years. But an issue for us has been, how do we actually process the data? And so this has been a very much PI-driven data processing, where you would have the data that are collected by this IPI, and then they would do a raw data processing every 3 months, and then every 6 months we would process it to sort of gap-filled data and partitioned. And that would be done by the central node, and then the corrected data would be submitted to the TERN data portal. And this was driven by Ray Looning here, who one of the godfathers of flux science in Australia, would always go, know thy site. And the Flux site PI would have to do the data processing, and nobody else could be involved, because you know what went on in this site, and you have to do it. And of course, this is challenging then, because not all site PIs are highly experienced flux scientists, and this is happening more and more and more. So where we want to get to in terms of ecosystem processes as part of OzFlux is this, that we have a central node that does the data processing, but all the towers are more or less connected to the central node, that we're streaming the data online, have a daily sensor data visualization so we can see which sensors are working, which ones are not working. That we have then almost an automated, if not semi-automated, sensor feedback that we can go back to the IPI saying, look, this sensor is broken, you need to go out there and fix it. We can give site advice in terms of people that want to set up a flux tower, how to do this, where to do it, what to look out for. And most importantly, we do data analysis and quality control so that we have a daily data upload, almost a weekly scan of data to make sure that everything's working as it should be. But of course, and here's an example of our data visualization. So this is stuff that we've already done in terms of connecting flux sensors on an online basis. Every half an hour, this will be updated, and you can see, if your fluxes are working, if your battery is okay, if any of the sensors are down. So this needs to be currently looked at by somebody manually, and then contact the site PI, and hopefully this can be somehow automated. But one of the challenges is that, of course, we in Australia as TERN ecosystem processes, we're not alone. We have our 18 sites, but we also have 3 flux towers as part of the Australian Mountain Research Facility. We have the Australian Long-Term Agricultural Research Flux Network, which we don't even know exactly how many flux towers they're operating. Peter says it's 20. I think it's maybe more like 15. And if you call Dave Rawlings, he might not know either. Then we have the other sites in OzFlux that are not funded by TERN, which is about 10 existing flux towers. Then we have the Critical Zone Observatory, 5 sites that are working in this project. We have a new long-term research project called the Net Zero Agriculture Cooperative Research Center, funded by the Australian government. 10 years of research just kicked off. What do they want? Flux towers everywhere, of course. These are not flux scientists either, right? These are agricultural people. And then we have what we call private flux towers. So the many folks that go out there to Lyco and Campbell and just buy a flux tower and put them somewhere. And so this is presenting challenges, because we would like to go to a more sort of less IPI-driven data processing, where we go to, data gets streamed in, the central node data people and the text look at the data and process them. And some of my thinking and Peter's thinking probably has been heavily influenced by the last 2 or 3 days that we had here talking to you folks about the FLUXNET 2025 data shuttle. But the issue remains, right? Know thy site, Ray Looning. My view is, yes, we can do this in a more general sense. So, but then the question is also, how much is too much, or how many flux towers is too much? Because if you add to our existing flux tower network all the other ones that we're operating in Australia in the same way, with data streaming, data visualization, data checks, who's going to do this? And do we have enough people that can go from raw data to half-hourly averages? And the answer is probably no. So maybe we can do the data visualization, checking and processing for the sites that we currently operate, but help with the data processing of the already what we call level 3 half-hourly average process data then through the shuttle. So this probably makes a lot of sense. So to sum up, I think one of the issues that we're facing here is that there will be many, many more PIs that are operating flux systems in the future. We also have many more site PIs that are not scientists, like most of us are in this room. They're people who have a very limited understanding of eddy covariance and flux science. And they would use any software to come up with some data because they go, "Yeah, look, mate, I need a flux data to know how much soil carbon I got in my soil." And then they just put it there and hope they press a button and get an answer. And of course, that's not the way it would work. But how do we help these people? Because if they actually get these data, get the data out there, get them published, then they'll get used by modelers and the data might be wrong. And I think this is an issue. So how can we assist these people is something I think doesn't keep me awake at night, but it's something that, we keep discussing and we don't really have good answers for this right yet. So how can we ensure minimum quality in data flux processing that is on a half-hourly average, where we can assist people that have a limited understanding and finding the right balance between this quality control and flux data processing and automation. Thank you.
Great. And we have time for a question or two.
I had a question about the private. You were saying that there's this whole private sector, right, that's emerging, and they have flux towers. And are they kind of sharing data with you, or how is that kind of coordinated? Because I don't think AmeriFlux is doing that sort of thing right now.
We don't know.
Okay.
So if we would know, I would really like to know. But the issue is that if you talk to the people at the back of the room, they'll tell you how many flux systems they're selling, and it's hundreds a year. Well, there's not hundreds of people here. So clearly there are people who are operating flux towers who are not part of our networks. And how do we get to them? This is, I think, is a challenge, and one that, as a director of OzFlux right now, I think it's a big challenge. We've got some ideas how we can start talking to them, but I think it's a challenge for us as a community how we're engaging with the people.
Thank you so much. I'm sure you'll hear lots of feedback on how to assist.
Thank you.
Great. And next up, we have Jen Diehl from NAU. So we're going to a different type of air site in the Southwest.
Great, shoot, it's not letting me share. But I can just plug in, right? Okay. Okay, 1 second. I do feel like I'm smack in the middle of some pretty established networks. And I'm going to talk about a proposed network. So, 1 second. I think that should be good. Okay, so hi. Thank you so much for coming and listening. I'm really stoked to be here. My name is Jen Diehl. I am starting my 4th year as a PhD student at Northern Arizona University, and I'm here to talk about kind of what I'm proposing and just to kind of get everyone aware of what I'm thinking about. So just over 2 weeks ago, I hosted the Great Thermal Bake Off, which kind of was fun to kind of come up with, as you see here, and I'm just going to kind of talk about some of the outcomes of that and what we're thinking for the future. I was kind of fortunate because Keenan this morning gave a lot of background talk about why we should care about canopy temperature, but I think that this graphic is super great. This is from Chris Still's paper. He had to duck out, but it kind of is showing how canopy temperature in particular is really like integral and playing into all these like fluxes that we're thinking about. And I think one thing that I'll just add is that we, and a lot of our models, use air temperature as a proxy for canopy temperature. And what we've been seeing is that those like really deviate from each other. And another kind of caveat of why this like proposed network is really important is in the next decade, there's going to be 3 major thermal satellite missions that are going up. And so we're kind of working with them to kind of establish a ground truthing network. So yeah, this is a map of the known thermal camera sites. I say 18 question mark because every time I give this talk, somebody else is like, oh, I have a site, which kind of goes to show we really need to establish a community and kind of figure out where all these sites are located. But in seeing and, seeing from these other talks why canopy temperature might be important, we've kind of been surprised. Well, there's been like just not as many people incorporating it in their research. And a lot of that has to do with like challenges and like accessibility and usability. A lot of this is really a black box. Everything that's above 0 degrees Kelvin is emitting some sort of heat. And so your camera is getting that, and it's really hard to discern when you're interested at, 20 meters away, this little piece of this specific evergreen tree. And so a big thing that I tried to do in this workshop and a lot of my PhD is about trying to make this more accessible to all of you to then potentially put cameras on your towers. And so we kind of, Andrew and I had a nice little picnic and kind of came up with this idea. And this is kind of the team that came together, some of like the thermal experts. And we really wanted to come up with the most comprehensive way to start laying this foundation. And so what did that actually look like at this workshop? So we did a series of kind of lab testing and then field testing. So you can see one snapshot of the lab testing here on the left, where we had over 13 roughly cameras. Some cameras go in and out. That's kind of how it goes. And 6 different brands and within those different models. And I think it was a really awesome opportunity to kind of see how are people using this right now and like what is the best, for this science question or this science application, what would we recommend moving forward? And so kind of analyzing this data, again, this happened 2 weeks ago, so this will kind of be forthcoming. But beyond kind of the testing, we did like lots of talks about like what are the questions that like this kind of technology can help us answer. And so it was really awesome to have this like, we had roughly just under 40 people. We had representation from 10 different countries, over half identified as early career. It was just a really like awesome group of people. And I think like we really came together to start like having these conversations about what this would look like moving forward. So I will leave you with kind of the outcomes and next steps of how this is going to shake out. So we're going to do this camera comparison analysis, which ones were performing well in these like different settings and kind of what would we recommend. So that kind of plays into the next bullet of we're kind of coming together as like this group of writing a best practices paper. So if you wanted to set up a camera on your tower, you could refer to this and it will really outline the steps to do so. And then just building out this network infrastructure. I have the pleasure of working under Andrew Richardson, who has done this really successfully with PhenoCam. And so kind of working with that framework to start doing this with a thermal, like near surface thermal remote sensing. And what you're seeing here on the left, I have talked to several of you about this. But the PhenoCam model of Stardot actually is discontinued. So that's been kind of fun for all of us. But what has come out of that is we have started designing our own. And so that's kind of, you're seeing like a CAD image of this on the left that actually has like your PhenoCam, which is your RGB, your near infrared, and then your thermal all in one housing. And so what we're kind of proposing is that you would buy that from NAU and you would receive it almost ready to go and kind of tweak it for whatever like temporal interval you're interested in. And so I'm like happy to chat about more of this. I will just leave you with my email if you're interested in getting involved. I'll also do another plug. We've kind of heard from folks that because it's the year of remote sensing, there is some like money for PIs in the survey that's going to be forthcoming about money to get these thermal cameras. And so the goal is that maybe this is really good timing as we like make this like opportunity more accessible for folks. And also we have a FLUXNET working group. It's called the Canopy Thermal Imaging Committee. And so you can reach out to me, not Crystal, and we'll be having a meeting before the end of the year to kind of talk about all of this. And if you want to be involved, we would love to have you. So thank you.
Thank you so much. We have time for a super quick question. Are there any questions out there?
Thanks. Can you hear me?
Yeah.
Okay. I'm wondering if there's a distinction scientifically or with this effort between a thermal imaging camera, similar to a phenocam, where you get each pixel, you get that thermal temperature, versus something like a thermal infrared sensor, which has a wider field of view and gives you a scene average. Is there a distinction there?
Yeah, so I think Dave was kind of alluding to this before, so thanks for that. But it's a mixed pixel. So like the benefit of looking, an IRT is a mixed pixel. So in that, even Keenan's talk was saying it's kind of like can overestimate because you're getting not just your leaf temperature, you're getting bark or bare ground, which is usually warmer. With an imager, you have a lot more like kind of ability to look at different things. Like you can average over the entire scene, or you can look at this deciduous broadleaf and this like evergreen conifer and not get those branches kind of changing what that temperature is. So it's more accurate. But again, I think it depends on your question and it depends on your ecosystem, where that would be a good option.
But for this network, you're talking about
Oh,
actual
imagers.
camera, right?
Yes.
Okay,
Yes.
thank you.
Thanks for clarifying.
Thank you so much. Great. And we are going to head down to Mexico. So our next speaker is Tonantzin Terraza from UNAM.
All right. Well, thank you, guys, for presenting me. I didn't bring a timeline of Mexflux, but Alex Cueva already presented the timeline yesterday, and I think we are like 15 years behind the OzFlux timeline of the timeline that Dennis Baldocchi just presented. So what I brought here today, it's a short update of what has been happening lately in Mexflux. And so yesterday we got a good question from Kel. What does it mean of being a national laboratory in Mexflux? So we are now much better organized as a network. So we are representing already 13 institutions, and we got this recognition by the Scientific Council, Scientific National Council, which, by the way, it's not going to be like a scientific council anymore. See, with this new government that it's taking place in October, and it's going to be led by a scientist, the new president. So we're going to have a department which is going to be more connected with the government, and we are really hoping that it's going to bring us more resources for Mexflux. And so we also have lots of challenge in our network and as it Latin America, but I don't really want to talk a lot about our challenge, but I want to talk this time about the power of community that I have seen in the last few years and more and months working with AmeriFlux and FLUXNET. So some of the things we have gained recently is inclusion and collaboration, access to advanced learning opportunities, and technical and financial support. Some of us has been part of the steering community in FLUXNET and also in AmeriFlux. Aliper is already representing and in the steering community of FLUXNET, and he also helped a lot with organizing this meeting. And we have yesterday the presentation by Alex Cueva, who gave a plenary talk, which I think it's great to have these opportunities here in this community. And also a few scientists in Mexico are working and joining specific projects like the CLIPS project that is led by Leila Hernandez. And this work is going to be presented in AGU this year. Some other collaborations that we have had is joint seminars with AmeriFlux, and those are available in the YouTube channel if you want to see our sites. There is so much good science and exciting sites that we have in Mexico, and I really would love you to go into YouTube channel and watch these presentations. Also, the second one program, scholarship, has been great to connect more with the students. And I would like to invite students to come also to Mexico or in any other country in Latin America to do science with us. And we have received invitations to work and participate with Arndt, the NASA project, and also with Pangea. And some of the advances we have had in learning opportunities has been that many of the lectures of the Flux course are now available in Spanish and open in the FLUXNET website. And also we have had workshops in Mexico, and we have led a few breakout sessions within this meeting the past 3 or 4 years, especially in virtual sessions. And there is another workshop that is coming, and it's being organized and supported by NEON. That's gonna happen early next year in Mexico. And we also found or got the support by the DOE to have the first Flux course that is going to happen in Spanish in Latin America, and we call it TAFE. So this has been helping. This collaboration has given us a lot of financial support, which is important because we really struggle a lot to get financial support from our governments and institutions. But we got travel grants. We have 2 common workshops supported by the DO, as I say. And of course, we have access to the AmeriFlux mail list and all technical supports. But there are so much more opportunities that we would like to you guys to see and be part of building this great community, because we really want to be part of this community, and we're really happy to be here. And I think we can gain a lot by collaborating together. And also, if you don't mind, I would like to say something in Spanish in case there's more people that speak Spanish here or in the webs in the Zoom. But I think it's great to have more people from Latin America to come on board. Quiero decirlo en español, que hay muchas oportunidades que hemos estado ganando como red Mexflux por el hecho de colaborar con las redes más grandes que son AmeriFlux en FLUXNET, y me gustaría mucho que la comunidad Latinoamérica empezara también a sumarse, y creo que TAFE o este Flux Course nos va a dar esa oportunidad de conectar, y ojalá puedan venir también a nuestros laboratorios. Gracias. Any questions?
We have time.
Thanks. Oh, okay. I was wondering, out of the ones that you presented, and it's really great to see all of the different opportunities, are there ones that you think will have a particularly long-term effect? Because I'm trying to think about like which activities are most suited to like long-term capacity building type of advancements, right? So are there ones that you think are particularly important for that? Or do you think that they're all kind of long-term impacts?
No, well, I don't really know the answer.
You can think about it.
Yeah, we should think about it.
So I have a question.
Yeah.
So between now and next AmeriFlux meeting, what would help bring Mexflux in to be more integrated? And what would help bring in more Latin American researchers and scientists into the fold of the Edicovarians community?
Oof, that's a good question. Don't know the answer either, but I think there is a lot of work that we are doing, like being consistent, like sending emails, calling people to work and collaborate, being in workshops, and we kind of making a lot of networking within us. But I feel like people, they are already more open than never before. Like people really want to share data and collaborate. But yeah.
Thank you so much.
Thank you.
Great. Well, we'll head across the ocean to Italy with Dario Papale from the University of Tuscia.
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 Tuscia, yeah. Okay, nice. Okay, I will try to be fast, although it's not one of my characteristics. So I will avoid to go too much in details of what is ICOS, what is doing, and so on. But some basic information based on the question that I got is something that I want to explain. So first, what is ICOS? ICOS is a subset of what we have in Europe. So it's a long-term infrastructure that, as you can see here, as at the moment 44 class 1 and 2 stations, that is equivalent to the core sites in AmeriFlux or the TERN super site in Australia, and 59 associated stations, that is something like the AmeriFlux sites, I would say, with a little bit more pressure on sharing the data in time with full metadata and not complaining about the BADM. And then we have other 100 sites that are part of the European network that we serve, where I count only, and that's the new policy that we apply, I count only sites that send the data and accept the CC BY. If they don't send the data, or if you don't accept the CC BY, for me, they are nothing, basically. They are someone there, but I don't care. Now, how it works in ICOS, ICOS is funded, the stations and also the thematic center processing them is funded by the member countries of Europe. So it's not European money, but they are coming from the single country in Europe. So Germany is paying for the German sites, Italy for the Italian sites, supporting the stations, plus they pay a fee to the common services in order to maintain. So that's really different from AmeriFlux. There is no flow money from us to the station, but it's from the station to the ICOS services. Now, of course, that's requires something back, and we try to give a service to them. That's just to give you an idea of how the pipeline is working for the processing of the data. One of the characteristics of the ICOS stations is that in ICOS is that we process raw data. So this rail union statement is true somehow, but we know that nowadays more and more the technology, the capability to process the data and ensure that everything is documented and have a proper uncertainty estimation is something that we can do. We did test, of course, for this, comparing what we can do centrally and what the PI can do. So what's happened is, just to give you an idea on these sketches, that in fact, every day the station send automatically the data to our portal that is in Sweden, so it's not in Italy, while they send the metadata and keep all the information for the raw data processing that we will discuss in the afternoon in the second session, if you want, the one of you interested in Italy. And then we have a set of tools and query system and codes that just run automatically every night or every morning that check just if we receive everything, if everything is fine in terms of raw data. Otherwise, we send an email to the PI automatically during the night, and then in the morning, fluxes are calculated, and a near real-time product is delivered and published on the Carbon portal, again in Sweden. So basically, we take the data from Sweden, PI submit metadata to us, we process and give back the data to Sweden that they publish on the website. And we do this on a regular basis. So we have a flow of data production in ICOS that is similar to what also Stefan presented. So we have a near real-time data product that all of you can see in a Carbon portal. So if you connect today in the Carbon portal, you see the fluxes of yesterday and the meta of yesterday from all the stations. And then twice per year, we just reprocess all the historical time series of raw data. So we always reprocess the full time series. So 5 years, 7 years of raw data. We reprocess everything, move everything through the OneFlux processing and publish the results. So twice per year, this is updated. One is at the end of our calendar year, that is also your, and it is not there. No, it's there, but it's not the vegetation. So One is basically happening in spring, and the other one is happening at the end of the growing season. So it's basically what my team is doing right now. So they are processing the data. So this is what you can find, and if you want, I can help you. The other to find the data. The other point where we invested a lot in the last year and a half is really to move toward a complete metadata system. So at the moment, what we have is that for each variable that you can get from the Carbon portal, in addition to get the raw data, because you can get the raw data directly, you also have information about the sensor that measure this data. And when I say the sensor, it means really the model and the serial number. And this is published and tracked in a fair way. That means that we can track back the history of each single sensor. And that is something that in a network like ours is becoming important because we are having, in order to have continuity, we are starting to have national hubs of instruments that are sharing in the network. It means that I have a sensor at one point. If it gets broken, I get a sensor from the hub, national hub, and I send this back. And then it's maybe going to another site. And so we want to really track the history of each sensor. So if something is found, then we can track back and understand everything that this sensor measured. And this is something you can see here. Is just an example. You see that this is a saltwater content variable, where there is also a preview. Okay, that's its own image. And you can see that this variable here, that is the same, that means was measured at the same position, in fact, has been measured along the time by 3 different sensors. In these 2 cases, they are same model by Centec, but 2 different serial number. So it's the same model, but 2 different really sensor, and before a certain date by a Campbell sensor. And that's help you also to understand if you see some jump in the time series and understand if it's real or if it's due to the fact that just the sensor is different, you replace it and so on. It's an effort, I have to say, it's an effort to build up something like this, but once that is in place, then it's helpful. The other thing that we are investing in recent years in ICOS is on the urban part. So there is a project that is ICOS City that is evaluating the extension of ICOS measurements in the city. ICOS is not only fluxes, it's also atmospheric concentration in ocean. But what is interesting here is that we are testing new instruments for multiple gases and also radiocarbon that is super cool, but is super complex, that is based on eddy accumulation, in fact, not really in eddy covariance, but radiocarbon, so C14 that can really be useful to disentangle and understand the source of fossil fuel in a urban environment. It's ongoing. We don't know where it's going to end. The idea is to learn from this and then discuss with the ICOS community and the stakeholders, put in the money, understand if they want to build up something that is a urban observatory in Europe, because we know how much they are important to the anthropogenic emission in cities. That is done all in the 2 towers. So we have all towers that are around 100 meters. So they really integrate over a large portion of the city. And we have 3 operating, 1 in Zurich, 1 in Paris, and 1 in Munich. The one in Paris, we had to say that we wanted to first at the beginning have on the Eiffel Tower. Well, the cost to just put a box like this, it was impossible. In addition to the fact that towers like this, you cannot climb yourself. I mean, you have to hire a company that is authorized, that has to clean the sensor. It's a nightmare. We in ICOS, since we really want and love standardization, so we have a number of documents of instructions that are equivalent to protocols that are available online. And the last 2 that we released is one is on non-CO2. It means that now all the class 1 stations will start to measure methane and N2O following this kind of standard protocol, and the other one is on automatic dendrometers. So Stefan, I saw that you wanted to put if you just want to have a look on how we organize things, just to not reinvent things all the time. So we are now developing all the data pipeline to follow them. And the other point is that in terms of metadata, now PI of AmeriFlux, believe me, you should not really complain about the BADM that you are filling in. The ICOS guys are filling in things that are, I don't know, 10 times more complex. Because when you want to process the raw data, you need a lot more information. But we continue to develop new ones just to make their life more complex. The last two is one that we discussed with a small group of people today during the break is on the management and disturbances, where we developed a new BADM in order to have really specific information of the management and disturbances happening. That is super important for cropland. It's not enough to say that you irrigate the cropland. That's not enough. I want to know how much water you put, when, how, if this is captured by the rain gouges and so on. And the second one is on raw data processing, metadata in order to explain how you process your fluxes. It's super important in order to really compare in a honest way data. These two are available if you want to. I can share, of course. And then the allometric relation. We are starting to collect and put together allometric equations so that we don't ask any more biomass. We ask 3 diameters and heights and the allometric equation parameter, and we calculate this. And finally, yes, for the data access, all the ICOS data are accessible through our ICOS Carbon portal. That's the address, the web address. That includes also the raw data, so the 10 Hz, 20 Hz data. If you want to play with them, they are there. Everything is CC BY. It means that we only need the attribution for that. That is super important for communities like ours, so that you correctly say where you got the data, and also all our processing codes are in GitHub, so you can also try to reproduce what we did using the codes. That said, if you want to see how to get the data, how we organize more in detail the raw data processing, that's we'll discuss later. The BADM, I'm here until tomorrow. Otherwise, you can write me an email and I can give you all the support.
Did I hear you correctly that the raw data, fast data are available?
The raw data, yeah.
Awesome.
For both the ecovariants, so the anemometer and gas analyzer and everything, and also the meteo data, because we collect the meteo data at the frequency that is between 20 seconds and 1 minute. And so these are also available. You can download them if you want to see the variability, whatever. So, but everything is there. Yeah.
Great. Any other questions?
Actually, I have a question. Why did you decide to reprocess all the data every 6 months instead of simply pending?
Okay. Yes. Well, there are different reasons for that. I have to say that, in fact, for what we call the interim release, that is the one happening after summer, we only process the year. We reprocess the full time series once per year in winter. And the reason is that there are some corrections, like the spectral correction, the planar fit, that really are based on the time series. In addition, we always give a chance to the PI to update some of the metadata or some of the issues. So in order to be safe, instead of tracking back everything that could have changed, nowadays is much easier to just. Also, because the final product, you have to remember, is that is done, the one that most people are using, that is the OneFlux, that is really based on on the time series, on the full time series. It's not yearly processed. So in any case, the final product is multiple year, and at the end, computationally and time, in terms of time, is easier to just reprocess with the cloud computing nowadays. It's not the limiting factor for us.
Cool. Thank you.
Thank you. And our last talk for this first afternoon session, we're coming back to Berkeley with Kyle Delwiche. That I will mess up your last name.
Right, hello everybody. Today I'm going to be talking to you about the FLUXNET coordination project. So some of you may heard of this before. This is an effort that started a few years ago. Trevor Keenan, Dave Moore, and Kim Novick put in a proposal to NSF to fund a network of networks to run a bunch of programs to support FLUXNET from an educational perspective, community building, and then data sharing. And so we have collaborators all over the world. Some of the networks are shown here. And so this is a really global international effort to build up FLUXNET and support FLUXNET. Right, so the governing body of this effort, we call ourselves the FLUXNET Community Council, and there are about 18 of us, 18 to 20 of us, so we rotate every 2 years or so, and these are representatives from all of the major regional Flux networks and some emerging networks. We meet once a month, 2 different meetings for different time zones, and we talk about a lot of issues related to FLUXNET. All right, we do a lot of different things. So I'm going to go over some of these. Secondments, I'll talk about those, workshops, international meetings, newsletter. I just wanted to get a show of hands. Who has looked at our newsletter, our FLUXNET newsletter? Yes. I was worried I'd ask and nobody would raise their hand. Okay, great. If you haven't, there's the QR code. So we put this out every 6 months or so. It has a lot of information about what the regional networks are doing, what individual people are doing. So I hope that that's a useful resource. If you have any ideas, let me know. We're open to suggestions. All right, Flux course partnership. I won't be talking about that too much today, but we there is some fund sharing to support Flux course, and a lot of working groups, community-led working groups. Okay. Last summer, a group of 91 in-person attendees met in Brno in the Czech Republic. And we had 4 days of Flux Science, community building, wine tasting. It was a fantastic meeting. A few of us were there. But it was a really wonderful opportunity to bring people from all over the world together to build this community network. A paper came out, a conference report, if you're curious to read some of the things we talk about. It's in that BAMS paper. All right, we also have a secondment program, which some people have referred to. So this is, we have money to send US-based early career researchers abroad for up to about 6 weeks to work with an international flux scientist on a range of different projects. The applications are due October 21st. Please come talk to me if you have questions. Some of our previous recipients who are, I know some of you are here. Can you raise your hand? Emma. Where's Justine? Justine was here. Hey, Justine. So if you have questions about it, you can go ask them. I like this quote from so Tristan is in the upper left there. He went to Korea with South Korea with Minsuk. The secondment program has undoubtedly been the best research and scientific experience of my career. I'm grateful for the people I met and the knowledge I gained, both of which would not have been possible without this great program. So if you're early career and you're in the room, I highly encourage you to apply. We've seen really cool stuff coming out of this program. All right, we also have a workshop program. So we also fund workshops. The application for that will come out in October. But these have to be in the US for funding restriction reasons, but international people can come, and obviously people within the US. And we funded 4 of these so far. You heard about one from Jen already. We had an early career workshop. The Early Career Network is very active. They hosted actually a virtual workshop where they had webinars at all different time zones throughout the world and a lot of really great programming. These should be available online, the recordings for these. Last year there was a workshop on linking optical and energy fluxes in Colorado. Was anybody here at that workshop? Oh, one person. All right. Troy. Oh, yeah. Troy, you led that, right? Yeah, Troy led that. Okay, great. Troy, if you have questions about doing a FLUXNET workshop, talk to him. And then you just heard all about this, but this is the Great Thermal Bake-Off, which just wrapped up last week. And Jen didn't share that slide. I'm surprised she didn't. I love this picture that's the group in a regular photo and then in a thermal photo down there at the bottom. So that was really cool. And there are workshop reports about all of these on our website. So you can learn more about them. And if you're interested in hosting one, if you have questions, please talk to me. All right, we have a lot of community-based initiatives. So a few years ago, we put out a call to the entire globe and said, if you are interested in leading something and you want people to help you work on it, it being whatever related to flux science you're interested in, let us know, and we can provide some support for that. And so we've had a few really excellent initiatives come out of that. And you've heard about some of these already. The open source code group, Maddie, Justine, and Cove are all here. So they lead this. They had a breakout yesterday on GitHub. They have a really fantastic website that they put together, a lot of resources for coding. If you have questions, you can talk to them. It's also on our website. So this is not all that these groups do. I'm just giving you the highlights from each of them. All right, education. So you've heard about TAFE. The education group, our focus, we have many goals. The focus so far has been on translating Flux course materials into different languages. We've started with Spanish. If any of you in the room know a different language and want to translate materials to other languages, we would love to have you. The excitement lately is around TAFE, so this Spanish language Flux course opportunity in Latin America. We're very excited about that. The outreach group, so you heard from Maya yesterday about the artist residency program. So this is a really exciting. We actually got a little bit of extra money from NSF to fund this program. Pilot, we hope it'll continue in the future, but to bring artists into the FLUXNET community to help us share our science better, I guess, broaden the scope of who we're talking to and who cares about our science. There's also a podcast effort, and I've seen the signs outside for if you have ideas for podcasts. So there's a lot going on in the outreach group. Maya and Jason, and there are people here in that community. So if you have questions, you can talk to them or me. It's on the website also. There's a methane and N2O working group. Sam is here. Sam is one of the leads for that. So they've been doing a lot of work. So not just on methane. I know you heard from Rob about methane. So FLUXNET methane, the version 2.0 is kicking off, and there's a workshop coming up in October that will help people with processing methane data. There's also a lot of work going on N2O and both the raw data processing and then the post-processing. So coming up with community standards and resources. So a lot of great stuff coming out of that as well. And then you heard from the thermal imaging folks. They just had their workshop and will start, I think, meeting soon, I heard, to continue that effort. So a lot of really cool things. That doesn't cover all of it, but there's been a lot of great activity. And I would say if you have an initiative that you want to lead and it's not on this list, let me know. This is a very open, anybody can run one of these, anywhere from anywhere in the world. So we're happy to add people to this list. I mean, there's a lot of great ideas in the community. I think that is the end of my portion. Trevor is going to come up here and talk about the data side of FLUXNET coordination project.
Thanks, Kyle. All right. I just want to talk briefly about the new data initiative that is happening, which is not new at all. 2015 was a long time ago. Since then, it's almost a decade, right? So since then, there's been a lot of development in terms of FLUXNET data and data provision to the community, particularly by some of the regional networks. ICOS, AmeriFlux, through AMP particularly, and OzFlux and TERN have been very active about building systems to process the data in a semi-automated fashion and make it available to people. So this has been building over the past few years, and it's coming to a head in 2025. It's the plan for the launch of the FLUXNET data system. You may have been in the breakout session earlier today. You may have not been. The room was a lot smaller than this one and not as full. So I'm presuming about a third of you already know what I'm about to say. Apologies to those who don't. We're going to update the FLUXNET 2015 dataset in 2025, and it's going to look very, very different. It's going to be a data system that continuously releases data that is processed by the regional networks and brought together within this data system framework. So this is super exciting, right? We're still all relying on FLUXNET 2015. Some of us also bring in data that is now available on the AmeriFlux website that is processed through FluxNet. If you're savvy enough to navigate the ICOS website, you can get also processed data set there from their various releases, and OzFlux too. But bringing this all together, and most importantly, operationalizing it in a way that allows it to be integrated and continuously updated from data from all around the world, not just those networks, is the goal, and super, super important. So we know the why, right? We know why we need to do this. This data is so valuable. The what I just explained, serious upgrade to data provision for the community. And so that's super exciting. And the who. So I think it's important to recognize that FluxNet is an international network of networks. And much like the spoon in the matrix, there is no FluxNet, right? You can't get up and go and get a job at FluxNet. There's no actual funding directly to support FluxNet. It's not a thing. It's just a group of people and regional networks who work together to make data available to the broader community and have various community activities where we build collaborations, right? It's what we like to do because we're scientists. But there's no actual FluxNet. So you are FluxNet. All of you, though a lot of you are from AmeriFlux or the Americas regions, also internationally, everybody in the world who's making flux observations. So we're gonna, for this effort to be successful, it means your engagement, it means your contribution, and we want to provide as many mechanisms for you to do that as possible. Now, I've also said that there's no FluxNet, and you're all FluxNet. FluxNet is everywhere all the time, to borrow Dennis's phrase. There are groups through which there is funding or resources being dedicated to support FluxNet. I just want to recognize those. ICOS in particular, AmeriFlux Management Project in particular, and OzFlux and TERN in particular, who are supporting the data processing through developing OneFlux basically to process data through to this data release. So this is the WHO, and the AmeriFlux Management, or the FluxNet Coordination Project and the FCC are very focused on community engagement in this process outside of the data processing. So next is the how. There are so many moving pieces into the how to get this done. There's a lot that's been done already by the regional networks. There's a lot of community activity and interest in supporting it. Over the past few years, we've, through the FCC, been building community and community support, which is super important for getting people on board or interested in sharing their data more publicly. It's much easier to share with your friends than a stranger, basically. But there's a lot more that's needed. So later this week, there will be announcements sent out to all the listservs, everybody kind of outlining in more detail what is envisaged. Also soliciting your input and volunteering for what you see yourself contributing. There are so many different ways to contribute. And so please do keep an eye out for that. Please do engage with the process. Please spread the word, encourage people to share their data through this initiative. And please feel free to reach out to anybody here who represents a regional network in any capacity if you have any questions. I would like to mention, just for clarity's sake, if you are in AmeriFlux already, your site is, you've shared data through AmeriFlux, it is in the system, right? It's not like you have to send data elsewhere. If you're in OzFlux, similarly, Australia, New Zealand, or in Europe are represented in the European database. If you're outside of that, you have to talk to Dario. Okay, that's all I had to say. Thank you all for listening. Again, please do check out the newsletter. I saw about 50% of hands went up. That means there's a lot of you who haven't experienced the newsletter. It's super cool. There's so much going on in the global Flux community that is represented there. So please do check it out. Follow us on X. If you want to. We do postings there, so or on the FluxNet listserv, definitely sign up to that. All right, thank you very much.
To check that. Great. Well, thank you guys and people for staying in this session. So we would like to introduce you TAFE. Thanks to all the people that has been behind this effort. Like Dave Moore, Margaret, Haley, all the educational team from FluxNet. Some of them are online, I believe. And so, yeah, we want to present you this project or this workshop that is going to happen next year. But we developed already some steps that we need to run through before we get to the actual Flux course or TAFE. I'm just gonna say TAFE. Okay, so we are here in phase 1. We are developing the curriculum and needs that we need to teach in TAFE. And this part, it's pretty important because students that are going to be taking the TAFE, they're not only Spanish speakers, but they may have different needs as their countries have. So that we need to be aware of that there's some differences because where we are or just, I don't know. So we need to keep that in mind. And we also are trying to find out who the instructors will be. And we already sent a massive, well, not massive, but we sent this survey and we got a really nice response. But although I'm happy, most of the responses were from Mexicans. So we need to find a way to reach more people in Latin America, like in Peru, in Colombia. If you know more people that are working with fluxes, they should also be part of this. And one reason is because maybe we are more organized as a network, as a regional network, Mexflux, but we know already that there are more scientists doing flux science in other countries in Latin America. So we are here and we would like to hear your feedbacks and in this curriculum that we are developing. So the second part is to have train the trainers workshop that it's probably going to happen in Mexico City. And we're going to have people that have already taught in Flux course. They will come and work with the future instructors of TAFE. So we're expecting these instructors are gonna be bilingual. Well, the people in Latin America who will be teaching in TAFE. And this train the trainers is going to be in English because we're going to have instructors from Flux course. But TAFE is going to be completely in Spanish for Latin American students. And hopefully that's going to happen next summer. We don't know where yet. And that's something that we need to figure out. And this is what we like to work and present you. This is the curriculum so far of what we think we should be having in TAFE. And I want you to take some time and look at it and maybe make more some comments. I don't know, someone in the chat commenting or saying something. Yeah. Margaret and Kaylee. Yeah.
If you have time, could you say just a little bit about how this maps to how it is different from Flux course or same? Just to go through those, because you said it would be a little bit different. Just be nice to hear. Thanks. I mean the existing Flux course. This is also Flux course.
Well, we need to start like saying that most of the students in Latin America that are now working with fluxes, they probably, many of them are undergraduate students. That's a huge difference. And that's why we need to develop a curriculum that it's going to bring all the bases, because I just don't have really the answer. I just know that, I mean, we've been working with Ana Maria, who may be there online, and Taylor And this like a work of maybe 5 or 6 people, and that's why we want everyone to come on it.
Sorry, I just had a quick question too. I was just remembering when I started, took the Flux course a long time ago. But one of the things I really liked about it was the modeling. They had like a little section on modeling. I don't know, Dave, if you guys still do that.
Yeah,
But
whole
I
week.
found that to be really helpful, and I didn't see it here, but maybe just wondering if you were thinking about adding that.
Yeah, that's a good thing to keep in mind. If we are going to have the modeling part included in this, that's a good question.
Hi. Just to put like more context on the needs. A little bit of the context of Mexflux is that we are users of the ecovariance technique. We are not micrometeorologists. Basically, the community in Mexflux has been grown from biology programs, I think from environmental sciences program. So what we need to think here probably, and this is let's make like a brainstorming about making the TAFE that can be something like ecovariance for biologists, starting from that point. So I mean, this is just a little context so you can know like the public that we have because it's a different context from the US. So it's not, I mean, I think that a few of us are engineers, right? It's mostly the ecovariance students. Well, the students that use ecovariance in Mexico are biologists, are ecologists. So that part is important for us because we need to transmit the part that, okay, the micrometeorology is important and you need to understand it. We need to give a step ahead of just being users, but also having a more understanding for that.
Yeah, and also one thing I think, David, we were talking about the data processing has become easier in the recent years than it was before. Like we kind of can process the data with more tools than it was before. So it will be great to show them like in the beginning, or it's not necessarily. What do you think? Oh.
Just that I agree, and also Alex, right? What Alex said, because actually we've seen a similar thing with Flux course. I think over the years, Dave's been involved much longer than I have, but I think I first went in 2014. And even then, many of the students were engineering students or students getting degrees in micromet or meteorology. And even in just those last 10 years, it's just a huge shift in the disciplinary background of the students that come because the applications are so much broader. And because we have tools such that you no longer need to do the raw processing of the 10 hertz data in MATLAB, which is still my preference, but you can use these things like EdiPro. And also, it's interesting what Patty said. Yeah, big difference, I think, between Flux course and what's on the screen here is that there's a whole second week to Flux course, which is the modeling. But we had a chat this summer where modeling is an important application of flux tower data. But again, now there's so many others. There's remote sensing or nature-based climate solutions, and so we're even rethinking how we think about that second week. Sometimes, not all the time, but anyways.
Online, so Tyler and Enrico.
Okay, can you hear me?
Yes.
Okay. Yeah, so I've been part of helping plan the TAFE workshop, and a lot of this stemmed from the FLUXNET education working group, and we started doing some translation of slides and documents and different training materials. Some of the people that are in the room probably provided some of the things, and we took things from the US-based Flux course, translated into Spanish, and now we're starting to translate to French. And the whole concept is to, allow for this training to happen regardless of language barriers. So it started there, and we started kind of talking about, you know, what a Spanish language course could maybe look like, and then it's all snowballed from there. So I think there's been a lot of good comments made so far, and really at this phase, what we have, I think what was on the slide there is just kind of some general topics that we pulled together. But we're really looking for feedback specifically from the people that might attend TAFE or the Latin America community. You know, what are the needs? We don't want to teach something that isn't suited to what the people in Latin America need to know. So regarding modeling, for example, you know, if that's something that is higher priority or lower priority, then we'll probably adjust the syllabus according to that. So we're really in kind of this information gathering phase of trying to decide what the main topic should be. I do think based on everything we've done so far, it will be shorter than Flux course. It probably won't be a full 2 weeks. So we will have to make some adjustments there. But I think one of the remaining slides will have a QR code to a survey that if you want to help contribute and you know, give more feedback and continue being involved, there should be ways for people to get involved on there. So yeah, that was just a little more background, I guess. Thanks.
Enrico.
Yeah, well, just commenting on what I heard. The people, I think, definitely going to wait or be expecting to be trained on the software, on the basic data processing. I think that is unavoidable. I agree that now it's easier to do it, you know, because the companies have offered the software to do it. But I think people will still be expecting to do that. But if we're thinking on a shorter course, like a 3 or 4 day, we can take advantage of perhaps do that part online. I think teaching the EdiPro or the EasyFlux or any of the tools that are available, I mean, you know, in a virtual session, a couple of virtual sessions, we can get a lot done. And by the time we meet in person, it will be easier to put hands on processing the data. At least people will be already familiar with the software, will know about the assumptions and etc. So I think we should definitely consider taking advantage of 2, 3, 4 sessions previous to the in-person. And one thing that we really need to consider, and I think this came to my mind with the comment that Alejandro was doing, is that in the Spanish literature, simple terms like gross primary production is not necessarily common. I mean, in the curriculums for basic ecology programs in the universities, they don't really teach a good ecosystem science course. You know, we still teach ODUM, for example. So concepts like ecosystem respiration as we conceive it now based on carbon fluxes, or GPP as we conceive it as a photosynthesis for a whole ecosystem, are still concepts that are not very well widespread in the Spanish community, in the Spanish literature. So we need to pay attention some on these very conceptual parts. So what's an actual flux? What's an actual ecosystem flux? And why is that with covariance we can measure it, and which ones we can directly measure, and which ones we pretty much model, and which one we can only approximate them. So I think this very conceptual part, a very basic ecology or ecosystem ecology, I think will need to be part of this TAFE training. I mean, every time somebody in my lab approaches here, the first thing I give them is the Chapin's book, you know, the Principles in Terrestrial Ecosystems. So they can start reading what is GPP, what is NEE, those very basic concepts, because they're not very common, I think. So let's consider that, I think. Thank you.
Alex?
Was Susana online, right?
She goes after you.
Okay, after me. So also we would like to hear like your experiences. I mean, your experiences about how you have been teaching to different audiences, because this is going to be a mixture of people from different countries. So probably we are here discussing from our Mexican experience, right? But what will happen when we have the students from Argentina, from Peru, from Colombia? So we would like to hear your experiences being like international speakers. It's like you do not only have speak in front of the AmeriFlux community, right? You all have been in AGU, EGU, the American Meteorological Society, ESA. So, and you have had these experiences of sharing your discoveries to different audiences. You have something else on top first?
Yeah, we have a whole queue going on.
Yeah, sorry.
I'd like to, yeah. I think it's an important question. I have a couple of experiences, both positive and negative. I've lectured in China at a short course, and I think it was a waste of my time. The students understood absolutely nothing. It kind of went over their heads. We were asked to give a high-level talk, and they're mostly undergraduates, to be honest with you. So I think I really endorse your desire to want to speak in your native language. I've been to the Brazil meeting, and it was all in Portuguese. I didn't understand anything, but Dave Fitzgerald and Jose Fuentes were there, and it went really well because they were able to speak under the language, essentially. And then I spoke at a short course with Jorge Perez in Chile. That was wonderful. We mostly spoke in English. It had students from Africa and all across Latin America. They're a little bit more senior. I think it worked well. It was a small group on ecosystem ecology. But I think you know your students better than us in terms of their languages, and I think you should design the the short course to serve them best, essentially. So that's all I was. Thank you, Dennis.
Susanna. Hi, everybody. I just wanted to contribute something. I was looking at the Flux course learning objectives, and I can see that it's very carbon cycle centered, and I think it's good. But I wanted to say that I think for our I don't know, for our context and everything. And I actually would like to say that also for the Flux course in English, maybe the interaction of the water cycle and the carbon cycle should be integrated as a learning objective, not only to be carbon centered, but this is very important for Latin America, and I guess for the whole world, right? Like Dennis was saying in his talk, the water and carbon cycles are coupled, right? And so a lot of the applications of using the Flux data it has to do with water use, with water use efficiency. And so I think I would like to see TAFE with the learning objective of both, of the coupling of these both cycles. Basically, that's it. Well, actually, I'm sorry. Now that I have the microphone, I also wanted to add that, yeah, it's true that a lot of the users of Flux data and the ones that want to have Flux towers here in Mexico are coming from the more biological or ecological background. But I guess it's because we haven't had a very good, I don't know if it's strategy, to invite students from that are being formed in the more applied mathematics or physics or even meteorology. And so maybe I hope that this course would be a good opportunity to bring together these other, disciplines that should be or could be interested in having, their hands-on Flux data. Right, that's it. But
something on your list of bullet points that caught my eye was the field safety piece, which I remember when we put together a resource for teams to develop kind of a safety code for their own site. We were in an international team, and we kind of quickly realized the considerations are different depending on which country you work in. So that's may just be something you can't just translate what's taught in Flux course, because there may be different things you have to take into account if you work in Mexico or Brazil or somewhere else that US scientists don't even think about. And then I know Margaret had her hand up, but I think Patty had her hand up first. I was just going to say, I teach very diverse undergraduate students all the time, and I think maybe one thing that could help is if you had kind of TAs. I don't know if you've thought about this, but maybe graduate students who could come you know, we have a lot of fluent Spanish speaking graduate students here. I mean, even in my lab, but across the US, who could maybe come down and help out. And especially if you're saying a lot of these students are undergraduates who've never worked with data, you know, processing the data in any pro or whatever, if you had more TAs or something, they could be more hands-on and like maybe less intimidating. Just a thought. Yeah.
Eating the Margaret is next. But Margaret is next, right?
Okay. I'm not sure if this is the order in which you might teach things, but it just occurred to me you might think of like a theory sandwich for that first one, and the bread would be actual field experience and discussion. So maybe think about starting with going out. What's an ecosystem? Walk a footprint, see a flux tower, you know, look at it, especially walk a footprint. Just think about it a little bit, talk about it, maybe have in your mind 2 ecology questions for discussion and seeding, and then theory, and then go back, perhaps like sort of a little sandwich there. I don't know, but a lot of people here have taught undergraduates and I don't. So, and then something I've heard people really like about Flux course is having a mini project, but here I'm wondering if you could do something a little more structured and maybe more modest. I don't know. So they are all reading the same paper, thinking about a question, and going out and making one actual field measurement. Doing one thing, and then organizing those data, or something like this, or putting their data on a plot that already has flux data on it. They're kind of interacting with what you get from a flux tower in some way that's structured and has a science question in mind.
I like Susanna's comments and Ricky's about obviously having some background on water and carbon. And I guess my bottom line is feel free not to recreate the Flux course. You know, use that maybe as inspiration, but you know your students, you know your needs, and start from scratch. You guys are experts and you guys will do a great job. You know, I mean, these are nice topics to cover, but obviously you have other needs you want also. So feel free for it. You should. So
I agree that we can do it. But I think we can also use this opportunity, as I said it in my presentation before, to increase our collaboration in this community. So if we create these mini projects, which by the way, I was a student in Flux course in 2016, and one of my PhD chapters was born in the Flux course, and it got published in Global Change Biology, and I'm very happy for it. So we can do that too, like use TAFE as a platform to increase our collaborations within the Latin American community and also AmeriFlux, because I think we are working together. It's not that we're just gonna go and do it in Spanish, but we want you all to be involved too, because you guys are part of it.
I just had a very quick thought following on Patty's comment about having TAs, that if it'd be helpful. We've had many students attend Flux course in Colorado from Latin America over the years, and so we could reach out to them directly if you wanted to pursue that opportunity. So people that attended Flux course that are from Latin America, maybe some of them are able now to serve as instructors, but it is really useful to have those TAs or co-organizers or people helping with logistics. And anyways, I agree, Patty, and maybe we can help if you also agree. Ellie?
Hey, how you doing? Can you hear me?
Yes, we can hear you.
Okay, yeah, I just want to say something related to what Enrico said a couple of moments ago about and take something related to the difference between academia in the US and in Mexico, or I don't know if it is the same in Latin America, but for example, in the case of Mexico, we don't have like the figure of the TA, right? Or the RA, for example. And the amount of courses that are available for even for graduate students, it's really limited. For example, when you study in the US, I mean, you have a wide variety of courses, right? For example, when I started my PhD, I was able to pick actually what I needed, right? And in the case of most of the programs in Mexico, basically they teach you what they have, right? So in that case, when people decide, I didn't go to the Flux course, right? But I've been working with eco-variants. So basically, you have some sort of background when you go there, right? You are not going from zero, from scratch when I think when you're going to Flux course. And basically in Mexico, and I think it will be the same in several countries in Latin America. I mean, I don't think people have an idea of fluid dynamics, for example, or maybe they never learn about something related to that, right? Maybe they are biologists, they are environmental engineers that maybe you need to lower a little bit the level of expertise that maybe you expect from the people coming from Latin America, because we are basically limited in that sense.
I'm not sure if this is true, but I think I understand the TAFE is being proposed to be slightly shorter than Flux course is. Maybe 4 days instead of 2 weeks.
Well, we haven't quite decided that. We need to look at numbers, and also we need to define how many students are we going to have in TAFE, and that kind of. Margaret wants to answer. Yeah.
Okay.
Yeah, right.
Okay, so the training the trainers is shorter than Flux course would
Yeah.
be. But I guess I'm only asking because a lot of the feedback that I'm getting is that maybe there should be more emphasis placed on sort of preliminary preparation for topics like atmospheric turbulence and just, the greater meteorological things that might not be as common in the student body, rather than sort of advanced modeling applications that might not be directly the point of the course, more so just collecting the data and being secure in how you're gathering it and troubleshooting the processing steps. So maybe that would be an optional sort of preliminary to TAFE, is that if you are coming from a biology background, you can just have a 2-day sort of intensive like atmospheric sciences course where you learn about, boundary layer dynamics, pressure, potential temperature, things that maybe aren't directly related to flux, but you should have a background in if you're going to troubleshoot what you're seeing when you start gathering data.
I will say just the way that Flux course has evolved over the years, I think this is true. Every day at Flux course, a quarter of the students are completely lost. Absolutely and completely lost. And they're different students every day. And that's good. That's okay, I think. So it's okay to come in and everyone has their expertise. I wouldn't, yes, starting from some sort of basic information and then building is good. I wouldn't avoid the hard stuff. I wouldn't avoid the really technical stuff, because someone will get it and then you'll get it. You'll have it later. You come back to it. I think of Flux course as an opportunity to know about a lot of things, meet a lot of people, find out who to ask questions of. So that's just one context to keep in mind, in that it's as a course. If I was teaching Flux course in my university, I'd be shot, right? It wouldn't fly as a course, right? That people would be complaining and grumpy at me and all that. But teaching it as a in conjunction with a networking activity, finding a friend. Oh, you know this and you don't. Okay, you sit together, chat about that, build a project. So just encourage that. That's all.
I don't know much about this topic, so hopefully this is not a dumb remark. Well, I'm also wondering how the education is there, and if the model of more of a flipped classroom idea would work, where a lot of these topics could be learned offline asynchronously the months leading up to the program. And it's not to make everyone understand it before, but just to be familiar. And then sort of the coming together will be more constructive because there'll be one nerd that will really have loved deriving all the equations beforehand that can help somebody else, and there's going to be somebody really interested in ecophysiology that can help the math nerd, and having that ahead of time, and creating the networking and just like the camaraderie in person. I don't know, it would accelerate that, and it would fill in some of the gaps where the lost students would find their buddies in person. And the other thing that I was wondering also is like how broad of like international, like how international is it going to be, and how collaborate. Like a really cool thing for students to come together is then to sort of like find collaborators to like go off with afterwards. And project ideas are really good to just start those. Yeah.
Hi. I think those are great suggestions, and Taylor, I think he's taking some notes, but yeah, we can keep that in mind, that we can send some material previews to the TAFE, and probably we can even, I'm not sure, I'm just thinking, we can even have like a test, like a minor test, or I don't know, like a ensayo, just to filter some students, because we don't know how many applications we're going to receive. That goes to your second questions, and we really need to do something, and perhaps here the FLUXNET Austrasian team can help us. How can we reach to more students in Latin America, where they are?
Yeah, it's also because I don't really know what kind of learners people are in the different countries, and if it would discourage them to have this homework, or would it motivate them to have this homework ahead of time? That's something that I have no idea, but it might be something you would be able to assess talking to the other instructors. But if it is something that would be motivating in the lead up to the course, maybe those are materials that the current Flux course could really help with put together.
Oh yeah. Yeah, if you want to promote the Flux course, I work with 3 Spanish speakers and would be glad to use those connections, or if you sent out to the FluxNet listserv or any of those things, it would probably reach the same people. But yeah, I work with one person from Costa Rica, one from Honduras, and one from Peru, who are all Spanish speakers, and yeah, all over the place. There's a small community at Louisiana State University. But when you were showing the last part of like the applications, I would be really interested to see, not just from Mexflux, but maybe also the other the Latin American participants who come to this course. I'm really interested in like how this might be applied to both the Afro-descendant and the indigenous populations that are currently like kind of targeted for forestry carbon offset programs, like the Red Plus program, and how you could use Flux data to determine how much carbon would be stored on their lands, their ancestral lands, versus like how much would be stored if they were continued to do their subsistence farming lifestyles. And I think that's a really unique part of Mexflux, is like the culture and the community and the environmental practices that you could observe that we don't have here in the United States.
Can you hear me? Okay. So I think that like some preliminary coursework would be really, really helpful, just to get a gauge for where people are at, and also like having a quiz or something like that, not necessarily to filter students, but to better inform instructors about, what topics should get maybe extra time in the classroom, and maybe to even bin students into different groups that could receive a different course. That if you have some students that are already have a background in atmospheric sciences or biology or vice versa, then you could even prepare 2 or 3 different flavors of the course to address those students' needs better, so that you can address all of them, but maybe you don't. I don't know. There's also merit, like Dave was saying, to having a mixture in the class so that people can be confused and teach each other. And so I don't really, I'm not a seasoned instructor, I don't know the best way, but as an instructor that's trying to make the most out of their limited time, especially if people are traveling from Chile to Mexico, that's a big commitment. And you might want to make sure that they get the most out of it over the time that they have. So I think a preliminary homework packet plus exam is probably going to pay dividends once the course starts, especially if you don't know, just to gather data, if anything, for the instructor.
Yeah, I wanted to follow up on Dave's point because I think it's important to keep the course at the level it has been. It's really important to teach the students what they need to learn. You have to realize, all of us, it took us decades to learn what we have. And so you shouldn't expect the students to learn all this stuff in 3 or 4 days. But they should be exposed to it. So now they know to go back home that I need to study this, I need to study that, especially if one student's an engineer, one's the ecologist, and one's a soil biogeochemist. They're going to come with different backgrounds. And so, but I think they'll go home, they'll know what books to read, they'll know how to network some more with some people, but they've seen what is the expectations that they want to achieve if they want to work in this space. And many will may want to work something else anyhow, so they won't. So yeah, I think we should be fair that way.
Thank you, Denise. Susanna has her hand raised.
Hi again. Yeah, basically I was going to say what what Denise just said in a way, and I wanted to just give an example. I teach a graduate course here on eco-hydrology. It's only 2 weeks and a half, but what I've experienced, and I have students not only from the institute where I work, but actually from from a lot of other universities and institutes here in Mexico. And what I ended up with every single year that I've taught this course is people coming from very biological background and also people from atmospheric sciences. And actually it's super rich that we are all together. So obviously in 2 weeks and a half, we don't delve into a lot of details on eco-hydrology, but what I've learned from giving this course is that how I do it is like a broad introduction into a lot of different aspects of eco-hydrology, right? And so what I like to think that I do, I think that we are successful here, is having like a baseline, so that when we talk about, like Enrico was saying, like when we say GPP, everybody knows what we're talking about. Or when we say evapotranspiration, at the plot scale, we know what we're talking about. Like, so everybody has like the same baseline. So I guess what I'm saying is that we could have like, and I also like the idea of the theory sandwich, because at the beginning, I guess it would be, and it doesn't really need to take too much time, to set these baselines. I had this experience when we talked about parcels in Spanish, parcela. I was talking about like an air parcel, right? But a lot of my ecology and biology students immediately had their mental image of a plot of land. And so it was you know what I mean? Like a lot of confusion there, because I was actually talking about a parcel of air. And so then I was like, oh, okay, I understand. So we need to like have a baseline, what I mean? But I guess when we develop this syllabus, I really like the idea of the theory sandwich. So we can start with like, with very basic concepts, and it doesn't really need to take too much time, as I was saying. And by the end, the last theoretical part could be a lot more advanced.
I think it's going to be awesome, and that there's been a lot of good ideas proposed here, and I think you're really set up success. Like if you wanted to do some sort of flipping in the classroom, you guys have already translated those lectures into Spanish, and so there's a lot of good material there that could be used to accomplish that. I was just going to share, at some point a few years ago, we surveyed Flux course alumni And we also have a whole bunch of feedback from that we take at the end of the course too. But actually, the survey of the alumni was interesting because it's like, what did you remember? You know, what do you remember now, or what do you use now that you got in the course? And the answers were all over the place, right? Because everybody took something unique away. But the one common thing they all shared was the people I met, right? And the connections I formed and the networking opportunity. And that is super, super duper valuable and goes a long way. And so I don't want to say it doesn't matter what you teach. Of course, it matters what you teach. You want to teach it in a way that you can allow them to maximize those opportunities. But that's just a really, really valuable thing. Yeah.
I just have to say that I feel like a kid in a toy store right now, because finally I can hear and put faces with the authors that I have read for a lot of time. So that's the feeling that I think that that we want to share with the students, right?
My postdoc attended Flux course, and he showed up and he's like, Kim, it is like the authors are jumping out of the journal articles into my life. And I'm like,
Tyler, I think that Tyler is the one. Yep.
Yeah, no, we've gotten a lot of good feedback. I'm taking notes here that I'll circulate to kind of our steering committee on developing the TAFE syllabus and whatnot. And I appreciate all the commentary we've gotten. I just wanted to say there's been a few people that have said, you know, I work with so-and-so in this country, that country. As Tonantzin mentioned, the pool of people that we have reached or that we've made contact with right now is heavily biased towards Mexico. So if you have contacts in other countries in Latin America, maybe at some point we can get, there are some QR codes on the last slide that we have. And if we can get people to contribute information to the survey, and just the networking component of this, I think, is a big aspect as well. And yeah, we just want to try to connect with as many people as possible and get feedback from as many people as possible within the community that we're trying to target. So yeah.
Thank you, Tyler.
I have another comment, and I had this idea when you gave your talk, actually. But I think it's relevant to this discussion and in terms of like building the networking, getting the word out that this is happening, getting interest and getting people, to know about it. And I'm going to kind of share the example of something that Layla has been doing. Or like Layla has a really good journal club on a topic that people are scared of. And it's been going on for a really long time. And I think it'd be good maybe to or how I see that these journal clubs are really useful is because like at a pretty regular interval, informally people just discuss a topic and meet somebody new and exchange, and that sort of like builds, and then somebody's like, oh, I did this thing, come next time. And then over the course of maybe 6 months or a year, you'll just have reached many people through doing that. And it would be an opportunity to share a paper in Spanish and then a paper in English, and maybe there could be like a US-based student organizing it with a Latin American-based student. They could work together, and it might just you were looking for ways to cross. And yeah, if there could be a collaboration between students from both places, and all they have to do is organize it, have a list of whoever is like interested in the paper, informally present it, invite their friends, and then that will sort of propagate. And the way that Layla does it, she actually records them and puts them on YouTube. And then somebody could go and just like look back in time and learn something about the discussions that happened. And it's super cool. I don't know if you want to say anything more about how this has been.
So thank you. Yeah, we have a YouTube channel on information theory, which is scary at the beginning, but then over time you start like hearing many times the same words, and it starts to make sense. And then yeah, at the beginning I don't know, but I also feel that for TAFE specifically, we also need to do some work before even started looking at who the final students are going to be, just because I'm from Colombia, but I've been working mostly in the US, so I have lost the connection with who is actually working on covariance towers in Colombia. And that's something that I feel the personal responsibility to know more about because yeah, we have been talking here during the meeting that there are many towers that we are not aware of. We are not knowing who is managing those. We have the responsibility, like the communal responsibility of informing better the right use of that data, right? So yeah, I personally feel the need to go back and check who is working on that in Colombia. We might be able to get to other countries. Yeah, but I don't know what else. Maybe setting up a YouTube channel or a way to communicate basic knowledge in Spanish may help. Yeah, it's just like from here to May or next spring when we want to do the first course, the train of trainers. We might be doing preparing some things to get there.
Yeah. So one thing I think we should do, I'm sorry, maybe Taylor, we can circulate again the survey after this meeting. So you guys help us to share and forward this email and this survey so we get more people in Latin America on board. Enrico?
Yeah, well, there's nothing that has not been said, just that networking is the best part of all these activities. I mean, that's definitely what people keeps from these exercises. The same happens with the isotope course that they teach now in New Mexico, for example. The experience there for meeting people, networking, standardizing techniques, and having somebody that you can now trust to ask dumb questions sometimes is very valuable. And I think that's just going to be exacerbated with the Latin community. I think I got the feeling that once we open these connections, the channels of communication will be a lot more stronger, I think, than other exercises that I've been close to. We have experiences, for example, with the Programa Mexicano del Carbono, when we've done some summer schools on different topics. I have witnessed how these students, keep connections for several years and exchange, for example, well connected across universities and cross professors in their committees, and share techniques and do intercomparisons in their labs and things, and everything came from these very basic exercises. When we were just teaching, for example, how to measure organic matter in soils, for example. So I think that's warranted, that just doing this course on the umbrella of AmeriFlux and FLUXNet and whatever network is involved is warranted, that it's going to be that it's just going to be the first time for this course, and we'll probably be able to do it every other year or so. So it's going to be very excited to see it happening. And on one question I wanted to pose to this table, because I don't think has been discussed, and Dave Moore in some meeting mentioned it. Do we want like one or two famous people in the course? I think that was once discussed, that, like you were saying this, suddenly I have all these people that I read and that perhaps is peer reviewing me. So I think we should definitely give it a good thought if it's or not attractive to have a famous in the room once the course is actually happening.
David, I'm sure David wants to say something about that.
Well, the way it's worked is I think that people come. Some people do want to come and meet their favorite flux scientist, right? So if you have a few famous flux scientists, it's a useful, that I think has been useful as a draw. Yeah, and it's kind of fun and it's good and it gets people to meet people they wouldn't otherwise. But don't underestimate the real need to find some people who really know how to teach things too. The overlap is not complete.
It's not a bad idea to have one or two famous people. There's one of the maybe it was the last time you lectured at Flux course, you were first or you snuck in or something. The students didn't know you were there. And then, we always introduce the instructors as they come in, and there was like this audible gasp throughout the entire room. He said, oh, and Dennis is back there.
Yep. Yeah, I just want to sum, the experience. I'm an alumni of the 2014 Flux course, and I'm the one of the completely lost during the course. And then I just don't want to add, the what I really value, what after, I experienced the Flux course was the meeting people, as you said, and then also meeting the people who I read from the papers. And this is something I really appreciated, and that really some kind of encouragement and also some kind of value by myself, the moving forward in the direction what we've been thinking. And the other part is the handling the actual instrument. That is a really something even I don't really understand. At the time, there's a lycra sensors in the lift level measurement we actually learned, and also we actually installing the eddy covariance tower, the sensor over there. And then that I didn't really understand, but the experience itself and the touching the machine and the instrument, that really, even I'm not completely understand all the fluxes stuff, but even I'm working the remote sensing, that really value to me, to meet the people and then connected with other flux expertise. So yeah.
To add to your comment, when I was an undergraduate, I had an internship with Jerry Hatfield, who was a biometeorologist at Davis, and he had me use the Barnes infrared radiometer to measure radiative temperature of wheat in the Davis field site. At the time, this thing was worth $15,000. It was more than the cost of a Mercedes-Benz. And as an undergraduate, to have this over my shoulder walking, it was so inspiring, and it gave you confidence. So I agree with your point. Yeah, I think it's kind of.
I have two questions that I would like to bring to the table too. And one that worries me now is that how are we going to do to keep TAFE going through the years? I don't know if you have ideas, but it will be great to hear them. And the other one is that we need to bring also these great companies that are here in the back of the room. Because they go to Europe, they always here in the US, attending all the conferences, but they don't really go they go sometimes, but how can we bring them here? Go to Mexico or Argentina or Colombia. And bring their instruments too.
Well, of course you should ask them for sure. But it occurred to me that if they are coming to some meetings and also other people you want to attract to the Flux course are coming to attend some meetings or could, maybe you can schedule the Flux course right before or after. So kind of there's a sort of a geophysical union meeting or a biometeorology, probably not, something ecology meeting, something like that. So that they get a 2-for-1 for coming.
That's a good idea. Enrico, do you want to say something?
Oh, no, I just forgot to down the hand.
Anyone else? I think we have a lot of notes. Taylor, I don't know if do you want to...
Ellie now has his hand up.
Who? Ali.
Can you hear me?
Yes.
Okay. Yeah, a question just came to my mind. A couple of weeks ago, we went to Las Cruces, New Mexico, to an AmeriFlux workshop with a lot of people of the Southwest. And one of the questions I got after the workshop, it was how much actually someone that is working with eddy covariance needs to know. I mean, because I remember several of the team members from the sites, they have an expert in programming, for example, programming the data loggers. There was another expert in telemetry. There was another expert in something, and there was someone specifically working with the final data, for example. So I was wondering how much actually right now someone needs to know about equivariance. Of course, we're kind of the old guard that basically we are jack of all trades, right? That we'll learn basically a little bit of everything. But I was wondering, actually, right now, how much someone working with equivariance needs to know actually. That's my question.
May I think that we are looking for people that fits the trifecta, that know how to do field work, programming, and also modeling. But that's difficult. But at the end, I don't know. At least I think what that the main aim of the TAFE as well as the Flux course is that the students have like a little bit of all the flavors, so they can at the end decide where they want to go or choose their career. They can be data scientists or actually going to the field or actually doing, I don't know, some remote sensing work. So yeah, I think that those are some of the aims that we would like to touch base with TAFE, and I think that is something that have been done with the Flux course, and I think that I know Dave is in there. Yeah, is that right, Ali, or didn't?
I don't think there is a right answer, but I agree with you.
Gotcha.
There is a comment online. There is a comment online.
Okay, looking at comments, sorry. Countries with low resources, people need to know everything because you're not able to have a lot of technicians. That's one comment. And then Susana said, we do everything because we're a one-person orchestra, but that's because we have no money. And just sort of a comment from me, I'll step this way. I think one thing that is important with a data processing course is to go out and read the landscape, because often people will just use the data, but without the context of the landscape, and to be able to tell, oh, this looks about right, or what was going on? So I think definitely go out to the field, stare at the trees, go in the morning, go at night, and read the landscape.
Well, I think we should wrap up. Yeah.
The hope here is that TAFE happens in 2025, and that would mean that Flux course in the US doesn't happen in 2025. So the next Flux course would be 26, and that would give us one of the advantages of that is that there's a European equivariance course that happens also in 2025, and it won't happen in 2026. And so we've been competing against the European course randomly. Didn't mean to, but it would be nice to sort of offset it a little bit. And so the hope is to try and get this going. I don't know if that's within the, I don't know. I would like to encourage that to happen. That would be wonderful if that could happen. But that's our current plan. The other thought is that there is yeah, that's all. There's no more thoughts.
All right. So I think we got a lot of great ideas, and we're going to put them all in a paper, and we're going to share again this survey that we already sent through the AmeriFlux mail list, so we can reach out to more people in Latin America. If you know people, please send the survey. And Taylor, you want to say something?
Tyler wants a Flux course in every language.
I did make that comment. No, but I guess I was just going to say, thanks there was a lot of really good points brought up throughout this. We're in this information gathering phase and trying to make sure that, what we're designing is what is desired. So no, I don't have any other comments. Just thank you everyone for the commentary and input, and yeah, be on the lookout for some more updates and various things. I have some notes here that I'll send in to Trevor, whoever was doing the breakout summary. So thanks everyone.
Well, thank you.
Nice to see you all.
Yeah.
See you.
See you.
Bye, Eli. Bye, Susana. Natalia.
Okay, we continue here in about 12 minutes.
Okay, we have 12 minutes break before the next session.
Hi, everyone. Well, this is coming back together out of after a lot of good discussion. We'll have the continuing theme of network updates and then report outs from the breakout groups. Right. Great. So I'm going to start with AmeriFlux network updates. Thanks. And so a little update on AmeriFlux sites. We're at 669 sites registered, so 40 new ones since our annual meeting last year. Point being that just in terms of sites and actually in terms of data, we continue to grow. It's really not leveling off. And I think having so many early career people here is kind of part of that excitement in the future. So really cool. And the data team and the sites that submitted actually added 30 new sites data in the last year. So we're at 498. Who here is going to give us 499 and 500? Who's going to submit data who hasn't yet? Yes. Woo! All right. Thank you, Alex. Thank you. Okay. And I want to just give a shout out to some special sites that have really long-term data in our network. We call these the core sites because our project helps fund the operations, but they're all managed by independent PIs who've been working on them. These core sites have high quality continuous data. I have the pictures of some of the mentor or the PIs of these sites because they also are really important for mentors in their region. You can reach out to people, and important to us for innovation and kind of being able to speak to experienced people in the network is really helpful for our project AMP. And so I think for the whole network. And just looking, the core sites include most of the most downloaded data, partly because they're older, but they're well known. So what's happening in terms of IGPP or vegetation type? Continuing from last year, we have this new thing where forests are not the dominant or most common sites in our network as they were originally, so cropland and then permanent wetlands. We now have more sites in water bodies, and that's been a question because it's hard to make good CO2 flux measurements over water. And so we are getting a lot of requests like, would we accept eddy flux data that doesn't have CO2? So just to say right now we're hewing to the AmeriFlux definition that this is carbon fluxes, that we have to have carbon. But I put it out there in case this stimulates discussion and maybe pushback. And we now have 16 urban sites. So that keeps growing, is pretty cool. So this is what we've got. I'm going to say AmeriFlux is getting wet with all those wetlands and water bodies. And so what do you get when you have wet ground? You have methane. So this is pretty cool. We now have 138 sites that are measuring methane with eddy covariance, another 30 using chambers. That's not all year-round data, especially like think Arctic. 114 sites have published data. So you can go get methane flux data now from 114 sites across the Americas, and 87 of those have data for more than 50% of, I think, at least 1 year. I don't know how long the records are. And then overall data, as I said, 498 sites. So just 2 years ago, I think we were at 3,000 site years of data, but we're just keeps leaping ahead. I guess the time stops for no one. So 3,000 almost 3,600 site years of data. And then we're producing the FLUXNET product. This is the gap-filled, partitioned, uncertainty quantified data. And we have data available for 196 sites. And we'll have many more by the end of this year. So stay tuned on that one. I've been told, let's see, I'll just say I didn't put downloads because everyone this week is saying, we just don't learn anything from downloads. What about people using the data? Well, I don't know, but here's what I could find, that AmeriFlux in the Web of Science has an H index of 147. That's probably more than most of us, I'm going to just say. And it keeps going up, up, up. You know, you can get a nice curve. I think Dennis showed one of these. And there's a wide range of applications. Since we started the year of remote sensing, we actually have seen a little uptick in the number of sites that are papers that are classified as remote sensing. We're actually starting to see that happen. So I keep saying that we in this project, AmeriFlux Management Project, is what I'm talking about. And we are funded by Department of Energy to serve AmeriFlux and the regional networks within AmeriFlux, like Mexflux. So we do data support, tech, community, and course sites. And so now I just want to give a few little updates. Third time you've seen this, or this concept. A Flux data system is coming. We've called it the shuttle. And it's connecting all the regional networks and making their FLUXNET data product available. Good. Okay. Phew. And this is a really neat initiative because it's not just this shuttle with the data, but it's also a group of people working and maybe expanding, bringing more of you in to increase the data holdings, to get new sites in and increase the visibility and impact of the data. And Trevor gave a great description of some of the things that'll happen for that. So that's the FLUXNET Community Council as part of that. Another data thing, this is the only other thing I'll say, is that Fiona O'Brien, if she's still here, has worked hard to create API services for getting what variables are in a data set, what's the standard variable set, downloading data. And what she's done is start the documentation. So we hope this will make it easy to use, and it's in a test phase. So that's what that QR code means. We're continuing to be really active in tech, meaning our goals there are to try to ensure that this wild coalition of the willing is collecting comparable data of high quality. So thanks to Sebastian and the whole tech team on that. And one thing I wanted to highlight is this resource that AmeriFlux can loan an EdiFlux system for up to 3 years if you have an opportunity. And I was mentioning this to someone yesterday, and she said, oh, but do you need a fire that's burned or like something has happened? I was like, no, you tell us it's a good opportunity and it's a special opportunity, and we'll work with you. So you define that. A new opportunity can be a really underrepresented region, for example. So Tonantzin, you on it? Yes, I can see the camera out. This is great. And one of the special resources here is eddy covariance in urban ecosystems, which used to be, we got a review in our last proposal that said, you need to do more urban. And we wrote back and said, no, we're not ready to tackle that. And Dennis really had our back on this. Like, this is pretty complex. Can't be promising to do too much. Well, the community now is doing it, and they'll bring us along. And DOE wants to support that. And in part, they want to support that because they're moving towards seeing that humans and what we'd call the natural environment or the other part of the environment interact. And they're kind of starting to embrace study of not just managed systems, but like urban environments and other human modified environments or with people in them. So urban is the first one. They have some integrated field laboratories. They're starting some climate resilience centers. And just to sort of support that from the side of the ecosystem environmental system science program, Dan gave us funding for 3 urban towers. They're rapid response systems, but they're prioritized for urban ecosystems. So I didn't say that very well, but hopefully you got the message. And also, I just want to say I thanked Sebastian, the tech team, I didn't specifically call out on data. I just want to thank, there's several people here, Yue, Danielle, Gilberto on FLUXNET, Saiton, a lot of people, and I'm Fiona, forgetting some people, I'm sure. Hausen too. He spans it all, does it all. Okay, I'm gonna think a little bit, go to more on the training side. We used to hold data tech workshops, and we still will, but we're kind of moving to something where we go out and do a little mini workshop at a different site. These have proven really popular. We had 30 people, maybe a few more, participate in the last one. And Sigrid Dangle has been leading these. So thank you, Sigrid. And this year we held one in West Virginia and in Las Cruces and or in New Mexico, I guess, to be parallel. And that was attended by people from the US and Mexico. And there were people joined online for part of it. And it's a neat thing because some of the time is spent just comparing notes, sharing their best practices, but what people are finding works. So if you would like to propose a region, hey, come host a day-and-a-half workshop in this area, or you want to host one at your site, please let us know. We want to keep doing a lot of these. I think they're really good. So this is just to remind me, of course, it's not just about sites, it's about people and our community. We know that, so I'm just going to move on. And we have a lot of events. We've heard about so many of these already, which is awesome. I'll just say, give a little shout out to Tonantzin Terrazas, who is organizing this initiative to have a Flux course in Latin America, where all the material and the instruction and the interaction is in Spanish. And it may hopefully will involve many countries. Maybe the first one will be in Argentina, for all we know, right? We don't know. First, there'll be the trainers workshop. If you were in the breakout, you heard that. And then the Flux course of the taller. And so this is a neat initiative. So I hope we all want to contribute to that. So keep us in the loop. Yeah. And thank you, Dave, for joining that. And I want to just give thanks to DOE, who has agreed to give a small grant, and it's just sort of pass through AMP. We're not doing it. They are leading this, but to support this effort, which is really cool. It will support the Train the Trainers workshop and the first in-person actual Flux course workshop. And I think it builds on what the Flux Community Council, I didn't say that right, FLUXNET Community Council is doing with the translation and all that. So these connections are coming together. I want to highlight a webinar series. We have quite a few, and it's always a good idea to go to ameriflux.lbl.gov and check the events page, all the time. But right now, something I want to highlight is Conflux. I think Christine came up with that name, but it's the confluence of flux and environmental research in conversation with Indigenous partners. We had 2 already. They were awesome. And a really exciting one coming up October 10th. So that's cool. We have some working groups. I'm just going to give a little shout out to 3 of them. And then I'm going to ask Andy Wimet to come up and speak for a minute. So wherever you are, get ready. So there's a nature-based climate solutions working group started by Kim, and she has made a lot of great things happen with this whole group's papers. And she just participated in a workshop for OSTP, the Office of Science and Technology Policy, which is in the White House, and also a NIST workshop. And I think Trevor also participated in the OSTP or in one of those, right? Or both? Oh, nice. Okay. I'm seeing back into the future. Very cool. But it's open. I'm putting the contact and saying Kim's name because you can get involved. The Urban Fluxes working group is going. Different things are happening. Workshop. There will be a report out soon on that. And as I mentioned, the Flux Rapid Response System resource. And then we've heard also about Leila Hernandez's Solar Eclipse Ecosystem Impacts Working Group. So they're using high frequency data to look at the effect of solar radiation, in the absence of other changes, because they could stop the solar radiation. They didn't. The moon did that. On things like photosynthesis and ET. So, nice work. Now, Andy, where are you? All right. Come on up. Thank you. This is just a quick thing. This is a different kind of group. All those other groups had a purpose to do something, to produce something. But Andy had this really good idea that there might just be like an affinity group. People could talk and learn from each other. So thank you.
Yes, thanks. So I'm Andy Ouimet. I'm at the U.S. Forest Service in New Hampshire. I just got there a year and a half ago, trying to take the place of Dave Hollinger, which I can't do. So, but I'll try. Yeah, it's been great. This meeting, there's tons of working groups, these global efforts to synthesize data. This is completely on the opposite scale. There's 8 of us that got together. We could grow this group, but we haven't decided if we want to or how to do that. Really, we didn't know each other ahead of time. We were all Forest Service or university partners with the Forest Service. We just kind of got on email with each other and then started meeting twice a week for the last, I don't know how long we've been doing it, 8 months or something. And I'll give a couple examples so you know what we've been doing. We just started, it's a great group. Everybody contributes. It's a couple PIs. It's people that are brand new to EdiFlux. But we started out with just sharing your site details, which is really easy, and then going through data pipelines, some of the stuff that we've been talking about global efforts, but trying to do like a best practice thing. So that's one of our efforts. We're going to try to compile how do you do this in sites in Colombia, which we have Tyler Roman with the U.S. International programs. How do you do it when you have to travel by boat to download your data, and as opposed to our course site where we have everything essentially automated real time. So there's a big difference in doing this. We're starting this intercomparison. How do we process high frequency data? So a lot of stuff that's been echoed, I feel like it's funny. We're doing this, 8 of us just getting on Zoom every couple of weeks and doing it. And it's been really helpful. I think it's still useful because it's a big learning experience for all of us involved, even if decentralized efforts go forward. So I'll leave it there. Thank you.
If I have an interview question. So if someone else wanted to start one, do you have one tip?
Yeah, I mean, I'm a shy person really to begin with, but I just started emailing. I don't know. I just looked around who's in the Forest Service. I mean, I could have picked people in the Northeast. Since I just started the Forest Service, we decided to keep it Forest Service oriented. We're missing people from the Forest Service. There's a lot of Forest Service employees that have flux towers. So this is our problem right now. With 8 people in the group, it's awesome. Everybody talks a ton every time we meet. And if we grow it, I haven't talked yet at this meeting because I don't like talking in big groups. So it's a hard thing to do. But yeah, just email people. It's fun. People were psyched. Yeah. Yeah.
Awesome. Yeah, I just think that is really awesome. They've been meeting twice a month, and this is for more than 6 months. I think this is going. So it's pretty neat and just organic. They just started it. So I wondered, just want to put it out there. Like, is anyone else interested in having discussion with other people working on the same system or sharing an affinity for thermal cameras, or you're very interested in wetlands or something. So those are just random examples, and it's really up to you if you have any interest. So I'm just going to pause now. No commitment. You're not signing up. I'm just curious if anything comes to mind for anyone like, God, I might join a discussion on X, or I'd like to compare notes with. Anything? Cool. Go, Jackie.
Just at lunch today, I was talking with somebody about a lot of towers are at LTER sites. So thinking about how to use long-term data from LTER sites together with flux towers more, talking about opportunities.
Anything else come to mind? Try.
So last summer, we hosted this linking optical and energy fluxes workshop, and we've kind of built a small community of people making tower-based remote sensing measurements, and we've come up with the help of some people in here, some metadata protocols and best practices to do that, and kind of have that in the format of a paper right now. And we've kind of been meeting informally, infrequently, but if anyone's interested in that, please reach out.
And was it Jason? Someone was just telling me they were comparing notes with John Frank, and they had both been doing the same thing to look at instrument stability. No, I don't see him. Okay. So it could be anything. Yeah. So if you have an idea, just contact us. And if you want help, you know, maybe I can help you say, yeah, here's how you use site search to find other PIs who have the same interest. Because maybe you don't feel like starting by writing to 2,000 people or 14,000 people on a listserv. Anyway, we can help you set up a first Zoom meeting if that's helpful, whatever. But I think this is a really great idea. So thank you, Andy, for doing that. I'm just going to end with a couple notes on year of remote sensing. There was already a breakout, so I don't want to belabor it, but we have these theme years to increase visibility, to get resources, to bring people together. We have a lot of activities, and just going to talk about a couple things. We brought PhenoCam online, meaning, sorry, that's really taking way more credit. You can now get PhenoCam information from the site info page on the AmeriFlux website. So that's all I meant to say with that. And there's some trainings coming up on October 11 and October 18th. So you can spend October 10th with Conflux, just stay tuned in, zoomed in, and the very next day you could attend a PhenoCam training. So PhenoCam's on, and GeoNext is next, and you all heard all about that, so I won't go over it too much, but here you can get, it's 10-minute data. So if diurnal cycles, or not worrying about having that you missed a whole month because the one 16-day return was cloudy at your site, something like that, then this is the data set for you. Another great opportunity is that we are going to be able to purchase sensors, 3 kinds of sensors to be mounted on AmeriFlux towers, and make these available throughout the network. I think that's international, but I'm just looking at you. Sometimes we've only offered these, been able to offer to US sites, so I'm not positive, and Sebastian will let me know. I just want to say one thing about how this arose just really quickly, and that is that we had this opportunity because we had the theme year. So our program manager, Dan Stover, said, well, do you want to make any requests like you did for the year of water and the year of methane, where year of water, we got all these sensors that we were able to distribute. And I said, yeah, but we hadn't been thinking about it. I thought the opportunity wasn't going to come up this year, but their budget worked out. So I could write to the remote sensing working group. They've already been thinking about it. Like Jen Diehl, we heard from her already, thinking about thermal. So we got great suggestions from the community, and then we were able to turn that into a little mini proposal that we submitted and we got funded. So I just wanted to give a sense of that. The other thing that's really happening with people's initiative is workshops. If you have an idea for a workshop, that's something we can try to help support. So we don't have a next theme year on the horizon. We thought it'd be good to just have people doing what they want, little things bubbling up. Let's see what happens, and aim for a new next theme year in 26. Okay, now we do have a few minutes. Questions, discussion. Community announcements, whatever.
You discussed this data flow, and you stress ICOS, AmeriFlux, et cetera, OzFlux. Asia and Africa is missing. How can we get them engaged?
Put out to those regional networks that don't have cross capacity. You will handle it. And OzFlux and TERN are doing the same in their time zones. They're going to be providing support and processing capacity to actually process. Then the FLUXNET Coordination Council is saying they are going to themselves, but also try to gather a bit more community to provide other kinds of support, like here's how you use a QA/QC. So definitely, yeah.
Maybe just a community announcement to that point. Asia Flux is meeting at the end of October, from October 30th to November 2nd. So if anybody in this room has availability of funding or free time to go visit and represent AmeriFlux or other national, international networks, then I think the more engagement directly with Asia Flux, the better.
Yeah. and AmeriFlux, well, has attended the last couple meetings and gone to Japan, Korea, China for that as well. But, and then I think other groups are as well. Yeah, let's see. Just seeing what was there. I think that lower left is supposed to represent quite a few more. Anyway. Anything else? Did have one other message. Oh yeah, this is really cool. Just wanted to say that yeah, the new president of Mexico was at Lawrence Berkeley Lab for 4 years. So so we feel a little glory reflecting from Mexico back to us. We're very pleased with that. Thank you. Yeah. And if there isn't more, I want to say this is the view if you walk 6 minutes or 5 minutes west of here, definitely west. Just, you know, go along the marina right there, go over the little berm. You can see the city, you can see Golden Gate Bridge. You can't see Avni because she already left. But it's close. So I hope before dinner tonight, you'll have time to take a walk. Anything else? I think we're moving to breakout report outs. So thank you.
Oh, there it goes. There we go.
Perfect. Okay, last business for the day, and then we all get a break, and then we all get to go eat. I'll be very, very brief. So if you propose an idea, sometimes you're kind of in charge of like executing the idea a little bit. So this was an idea to kind of keep the end of the day really, really succinct because we're all tired. It was a long day, right? So we asked the breakout moderators and organizers to send us sort of a few main points about their breakout session. So I have a few of them. I know that time was short today. So I'll read you what I have, and then we'll go through and I'll ask you to come up and I'll type in just a couple points, but we're going to keep it super, super short. And we'll save the discussions for dinner. How does that sound? Sound like a plan? Awesome. Okay, so from the early career day presentation yesterday or Tuesday, days are blending into one. Cooperation and production, co-production. Really, the goal of that session was to reflect and have an open discussion about flux science outreach and what outreach really means. And some of the major takeaways from that was that outreach is really targeted and that outreach means different things for different people, depending on who your audience is, what your objective is, what your activities are. But it is very important to engage with outreach during different stages of your program, especially if you want to build up your networks, if you want to inspire the users, and if you want your science to actually make an impact. Other synthesis and takeaways from it is there's shared challenges. So we all need to know how to communicate a little bit better and how to connect outside of academia. And how to practice building relationships beyond those with other scientists. We also need to create resources and opportunities and share those with the broader community. and really do a lot of co-learning to build outreach capacity. So that was a great session on outreach. The folks from Putting Your Code on GitHub, their main point was to get participants to learn and actually share their code on GitHub. And what is super cool is that they had an immediate outcome with 5% participants putting their code out there during the breakout session. So kudos to you guys. That is awesome. That's a big deal. Clap, 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 clap. And their next steps are really to just discuss and come together and figure out how they can serve FLUXNET better, and what that looks like, what kinds of resources and tutorials and workshops. And please reach out to this committee or to this group if you have any thoughts and ideas. So that was one of our first breakout sessions yesterday. I'm jumping to the last one of today because they sent their major takeaways. So this is from TAFE, Taller de Aprendizaje de Flujos Ecosistémicos. Major takeaways is that there's a lot of variability and a lot of uncertainty in the level of expertise of students that come and take these courses. And they have to deal with a slightly different audience that maybe we deal with the Flux courses in the US. So there were a lot of ideas floating around about considering some online sessions to kind of get ahead of the curve. So give a little bit of homework ahead of time, maybe a little test ahead of time. But there was overall an overwhelming support for this course and for the idea of generating and actually executing this course. The networking side of the course, we all agreed on, could end up becoming very, very important and impactful. And for their next steps, they're going to continue to refine the curriculum. Feedback is always welcome. They're going to plan their trainees date and personnel for next year. And they're going to recirculate a survey that they sent out in an attempt to try to reach out more people and get even more feedback on how to successfully design this course. Okay, and so with that, so I would love to hear a couple of main points, a couple of outcomes and future directions from leveraging Flux tower data for nature-based climate solutions.
Sorry, I did not read the instructions. It was a good session. Basically the point was to discuss ways to increase the visibility and use of Flux tower data for designing the implementation, prioritization, and policy around nature-based climate solutions. We had a little overview, and then we heard some flash talks from Marcy Litvak, John Knowles, Trevor Keenan, and Patty Okaiwa. And there's always a lot to say on this topic, but I think that I guess a few key points is that tower data are useful in a variety of spheres, right? They could be useful, for project scale monitoring, which is a lot of connections to the private sector. They could be useful for informing policy decisions at a range of public sector scales, right? So state, jurisdictional, federal, and for monitoring in that way. And then also that the civic sector, NGOs, are very heavily investing in this space. I think that if I could sum everything up into one takeaway, it seems that the examples we heard of people in our community who are doing this effectively is that it's really partner driven, right? If we want Flux tower data to be used in these contexts, it is necessary to talk to the actors in the civic, private, and sector space to find out to what extent our data could complement their efforts. So, I'm always thinking back, what's the next step for our working group or in this space? And I've been thinking that maybe for a while it's time to come back to this community. And I guess I left with the takeaway that discussing how to do partner-driven science might be an important thing for us to consider. Thanks.
Thank you. Our next one is Flux data sonification. So is anybody here from? Oh, 2 and 1, darn. My apologies. Could we just have you guys? What's up? Let's see, maybe Trevor. It might be on Trevor's. Yeah.
Thanks. I just sit here. Cool. So upstairs, we had fun listening to, or basically learning what sonification is, had some cool history examples, listening to things, talking about why we would sonify data, and checked out some tools to do it. And takeaways that, or sort of things that were said when we wrapped up, were that there are different roles and approaches to sonification when we are serving scientists, maybe to understand processes and data, versus serving the public to experience what's going on, and maybe new ways to do both. Sonification has benefits from both a data presentation perspective and a communication perspective. We have to consider how to best tell the story behind the data. Data sonification is a way to ingest lots of dense information that might help education and communication of really complex topics in flux science. And on the other hand, also help experience concepts and environmental issues that are challenging for the public to grasp. Sound listening creates connections to other people and with the landscape, which are important human things, community building and support around climate change, action and feelings. And a cool takeaway, or I guess final sentence that Sarah said to end our session, was that people will remember how you made them feel, not what you said. And we tend to forget that as scientists because we are very attached to facts.
That is true. People do remember how you make them feel, for sure. Thank you. Okay, what about contributing to a new and continuous FLUXNET data release?
Sorry, guys, I didn't do that. But the main point of this was to discuss we're all very excited about the launch of the new data system, the shuttle, which will allow us to have eddy covariance data from all over the world, hopefully in one place, in one format. And we were discussing ways to encourage new site submission and discussing ways to highlight the impact of this data and sort of build off that. And so some of the outcomes were some ideas for an annual paper to highlight some insights, some executive summaries of those of that annual paper, and then the need for community support. So finding tower teams that were very, very good at this and were old hands at submitting data to support those who are new submissions. And so I guess the next steps, there'll be a survey. We're going to be sending out a survey through the listservs to solicit more input and find some volunteers.
Right. How about bridging skills, integrating remote sensing and flux data for effective upscaling?
Hello. So our group has discussed about. So I started with introducing some of the recent and upcoming activities of the year remote sensing, and then also a new remote sensing related resources for flux sites. So as Margaret introduced, we will supply some of the proximal sensors for the eligible sites, and also we will be providing the visualization of geostationary satellite data set provided by NASA GeoNext. So we have discussed how these new resources could be applied to your flux research. So we wanted to kind of brainstorm how can we use the most use of it. So some of the research interest could be irrigation planning, plant stress monitoring, detecting rapid responses in dryland environments. So these are all related to the topic that can take advantage of our new resources that can detect high frequency responses. So I hope you could also think about how you can take advantage of the new resources once it is published later this year. And yeah, so based on this, all the discussions and feedback, we will be improving on our, the GeoNext webpage will be provided on AmeriFlux website based on your feedbacks. And also, we also discussed some of the education materials for proximal sensors that may not be very familiar to most of AmeriFlux communities. So that is one thing that you can take, you can move forward with. So with that, thank you.
And last but definitely not least, raw data processing.
I'll do the report so we can be brief, so it's not going forever. So we had this. It was a nice discussion. So the points were mainly the raw data processing done in a centralized way for AmeriFlux sites. The discussions were centered, can we do it? We discussed a little bit about this. Should we do it? Is that something that's worth pursuing? And is there enough interest in doing that? There are some good advantages for doing raw data processing in a centralized way. We get reproducibility of the processing for sites. We get comparability, improved comparability across sites. We get to try these new data processing methods, generating these very cool data products. There are some challenges as well, how to deal with all the metadata that would be needed in addition to what we collect, how to deal with the heterogeneity at the sites, of instrumentation, of options that the site teams have adopted in installing and deploying their sites. And for next steps, basically, we want to gauge interest in this. Are there site teams that would be interested in participating or seeing this, something like this happening? And if the answer is yes, if we have a good number, we can try to get a group together to assess how much work that will involve and what we can do within AmeriFlux. So that's basically it. So if you're interested, if you would like to see something like this happen, please reach out to us and we can start that conversation. Thank you.
Great. So record time, it is only 5:26 and dinner is at 6 p.m. Is that correct? Is that when bus leaves?
The
Six-
bus.
six. Great. Bus leaves at 6:25. And that's all you need to know. You just get on the bus and it takes you somewhere magical with food and drink. Great. So I guess we'll get a break, right? For a few minutes. So great day. Very productive. Thanks, everyone.